On a warm afternoon in 1974, humanity did just that. From the colossal, jungle-cradled dish of the Arecibo Observatory, we aimed a radio telescope at a distant, glittering jewel box of stars known as Messier 13, or M13. For 3 breathtaking minutes, we poured 1,000,000 watts of power into a focused beam of information, a digital letter hurled into the cosmic ocean. It was our first intentional message to the universe, a carefully crafted shout into the dark. But it was, as everyone involved knew, purely ceremonial. M13 is 25,000 light-years away. For our message to cross that unimaginable gulf, it would have to travel for 25 millennia. By the time it arrived, human civilization, in all its fleeting glory, would likely have risen and fallen a dozen times over. The reply, if one ever came, would be for humanity so far in the future they would be strangers to us. We sent it anyway, because sometimes the act of calling out matters more than the expectation of an answer. What we failed to truly appreciate in that moment of profound and hopeful symbolism was that we had already been talking to the universe for a century. We hadn't been whispering. We had been screaming. Every second of every day from the moment the first radio waves crackled to life, we had been filling the void with our noise. We were a young species that had learned to manipulate the electromagnetic spectrum long before we learned the wisdom of being quiet. Every baseball game broadcast on a summer night, every sitcom beamed from a television tower, every powerful radar pulse we bounced off Venus to map its hidden continents. All of it, every single transmission, was not contained by our atmosphere. It bled out, expanding from our world at the speed of light, creating an invisible, ever-growing sphere of human chatter. This is our radio bubble. For nearly 130 years, this sphere of ghosts has been racing outward, a testament to our existence. It is a shell of fading echoes, carrying the trivial and the profound, the beautiful and the mundane. The voice of a forgotten news anchor reporting a long-past war, the soaring melody of a rock and roll song, the inane chatter of a daytime talk show, all of it is preserved in that expanding wave, a ghostly archive of our civilization. Inside that 130 light-year radius, dozens of star systems have already been washed over by the leading edge of our presence. For any civilization within that sphere, Earth is not a silent blue marble. It is a source of constant, chaotic, and undeniably artificial noise. And then, starting in 2017, the universe began to send visitors. Not messages, but objects. Mysterious travelers from interstellar space began to arrive in our solar system with a frequency that felt unsettling. First came Oumuamua, a bizarre, tumbling, cigar-shaped rock that defied easy explanation. Then came Borisov, a more conventional but no less extraordinary comet from another star. Then came a third and a fourth, each one stranger than the last. What if our century of electromagnetic chatter finally reached a listener, a neighbor far closer than the distant shores of M13? What if these strange new arrivals aren't natural phenomena? What if they are the universe's way of finally turning its head in our direction and saying, in a language of physics and trajectories, "Message received"? Before we can understand the reply, we must first understand the call. We must go back and trace the history of our own voice as it spread into the void, to understand the 2 very different ways we have shouted into the dark. The first type of call was the accident, the radio leakage. This is the unintentional chaotic spillover of a civilization discovering its voice. Think of it as a child's room, a cacophony of sounds and lights with no thought given to who might be listening in the next room. This is the noise that forms the bulk of our radio bubble. The AM radio stations whose signals bounce off the ionosphere and escape into space, the powerful television broadcasts that paint the sky with our stories. This is the sound of humanity simply being itself. But there is a second, far more deliberate kind of call. These are the true messages in a bottle, meticulously designed and thrown into the cosmic ocean with purpose and hope. In 1972 and 1973, Long before the Arecibo message, we launched the Pioneer 10 and 11 spacecraft. Bolted to their sides were small, golden plaques, humanity's first attempt at a galactic greeting card. They were optimistic, perhaps touchingly naive. They depicted the naked figures of a man and a woman, his hand raised in a gesture we hoped would be seen as a universal sign of peace. They included a map, a sort of cosmic "you are here" sign, pointing from 14 known pulsars back to our own sun. To give a universal scale of time and distance, the plaques included a diagram of the hydrogen atom S spin-flip transition, the most fundamental process of the most common element in the universe. It was a message that said, "This is what we look like, this is where we live, and this is how we understand the basic physics of the cosmos." 5 years later, in 1977, we tried again, with something far more ambitious. The Voyager 1 and 2 spacecraft carried with them the legendary golden records. These were not just diagrams, but time capsules. They were a symphony of sight and sound, an attempt to capture the entire human experience on a 12-inch gold-plated copper disc. Chuck Berry's Johnny B. Goode was sent spinning into interstellar space alongside the haunting songs of humpback whales and formal greetings spoken in 55 different human languages. The records contained 116 images showing the breathtaking diversity of life and culture on Earth, a picture of a woman breastfeeding her child, diagrams of our DNA structure, images of our architecture, our art, and our family groups. The famed astronomer Carl Sagan, who spearheaded the project, called it a message to the universe. Others, more cynically, dismissed it as cosmic graffiti, an act of cultural arrogance. Either way, it was an audacious statement of our existence, a mixtape sent to the stars. But for all their poetry, the plaques and records were passive. They were physical artifacts that would drift silently for eons, waiting to be stumbled upon by some impossibly distant traveler. They were whispers. The Arecibo transmission of 1974, however, was a shout. It was the most focused, powerful, and intentional broadcast humanity had ever unleashed. Frank Drake and his team at the giant radio dish in Puerto Rico chose their target, the star cluster M13, and their medium with incredible care. They didn't send images or sounds in the conventional sense. They sent pure information, a stream of exactly 1,779 bits. Why that specific odd number? Because 1,679 is the product of two prime numbers, 23 and 73. It was a clever mathematical handshake. Any intelligent civilization receiving the stream of ones and zeros would presumably recognize the mathematical hint. They would understand that the only logical way to arrange the bits would be into a rectangular grid, either 23 bits wide by 73 bits tall, or vice versa. One arrangement would produce meaningless static. The other would reveal a picture. It was a pixelated diagram, a digital cave painting that told a simple, profound story. It showed our numbering system from 1 to 10. It listed the atomic numbers of the essential elements of life: hydrogen, carbon, nitrogen, oxygen, and phosphorus. It depicted the iconic double helix of our DNA. It showed a crude, stick figure-like representation of a human being standing above a diagram of our solar system, with the third planet, Earth, slightly raised to mark our home. At the very bottom was an image of the Arecibo dish itself, showing the tool we used to send the message. For exactly 3 minutes, the transmission blazed with the power of nearly 1,000,000 watts. In that brief window of time, the Arecibo telescope became the brightest radio source in our local galactic neighborhood, outshining our own sun. The signal, a testament to our intelligence and our curiosity, raced away from Earth at the speed of light, carrying humanity's first deliberate attempt at a real conversation. It was a beautiful, lonely, and almost certainly futile gesture. But what if futility wasn't the final word? What if the logic that guided us to shout also guided others to listen? In 1959, physicists Giuseppe Cocconi and Philip Morrison had laid out the very logic for this kind of search. In a landmark paper, they argued that if other civilizations existed, radio waves would be their medium of choice, and they even pointed to the specific frequency they would likely use, a quiet, protected sliver of the electromagnetic spectrum they called the water hole. This cosmic quiet zone lies between the natural emission frequencies of hydrogen, H, and the hydroxyl radical, OH, the two components of water. Any civilization advanced enough to understand chemistry would know that water is essential for life as we know it. They would recognize the water hole as a logical, universally significant place to listen for a call or to make one. Specifically, the hydrogen line at 1120.4 MHz became the holy grail for SETI, the search for extraterrestrial intelligence. Hydrogen is the most abundant element in the cosmos, and this frequency represents its most fundamental energy transition. It is the universe's own dial tone. If you wanted to establish a universal communication standard, a frequency that everyone would think to check, the hydrogen signature would be the obvious choice. For decades, our own searches have been guided by this elegant logic. The SETI Institute's receivers have patiently scanned the hydrogen line. The Breakthrough Listen project has monitored millions of stars across a wide range of frequencies. The logic is sound. If you want to be heard across the silent gulfs between stars, you broadcast where the galaxy is naturally quiet. Here, however, lies the crushing irony. As we have learned more about the universe, we have also learned more about the weakness of our own voice. Most of our television and radio signals, the very ones that make up our expanding radio bubble, are surprisingly fragile. The unforgiving inverse square law dictates their fate. With every doubling of the distance, the signal's strength is quartered. Within just a few light years, the sound and fury of our daily broadcasts, our sitcoms, our news, our music, become indistinguishable from the random background hiss of the cosmos. They fade into an indecipherable whisper, and then into nothing at all. Only our most powerful transmissions, our most deliberate shouts, have any chance of surviving the journey to even the nearest stars. These are not our television shows. They are the behemoth planetary radar systems, like the one at Arecibo, or the Goldstone Deep Space Communications Complex. Designed to map asteroids and probe the atmospheres of other planets, these systems are, by accident, our brightest lighthouses. Every time we use them, their powerful beams sweep across the cosmos as the Earth rotates, creating a distinctive, piercing signature that would be unmistakable to any civilization monitoring our small corner of space. So, for over a century, we have been broadcasting. Most of it has been a weak, fading murmur, but punctuated by deafening, accidental shouts. We have also sent our hopeful, deliberate messages in bottles, sailing on an ocean of unimaginable scale. We have been shouting into the dark, wondering if anyone was listening. And now the visitors have started to arrive. Not from 25,000 light-years away, but from the darkness right next door. They are moving faster than anything in our solar system should. They follow paths that prove they do not belong to our sun. They are here, and their numbers are growing. The question that keeps a certain kind of scientist awake at night is no longer just, is anyone out there? The question has become simpler and somehow infinitely more unnerving. What if someone finally picked up the phone? In the thin, crystalline air of the Chilean Andes, under a canopy of stars so brilliant they seem to tear holes in the fabric of night, a silent sentinel keeps watch. It is not a person, but a machine with 4 eyes, a tireless robotic guardian named Atlas. Its full name is the Asteroid Terrestrial Impact Last Alert System, and its purpose is as stark and vital as its name suggests, to scan the heavens for any rock that might threaten to end our world. Night after night, its automated cameras click and whir, methodically painting the sky in digital strokes, building a moving map of every object that wanders through our cosmic backyard. Sophisticated algorithms, the system's disembodied brain, sift through this flood of images, searching for the telltale signature of motion against the static backdrop of the stars. It is a lonely, thankless, but essential vigil. On the 1st of July, 2025, in the deep, quiet hours before dawn, Atlas found something that did not belong. At 03:42 Universal Time, a tiny point of light in the faint constellation of Microscopium triggered an alert. It was moving fast, impossibly fast. The object was already inside the orbit of Jupiter, a deep trespasser in our solar system, and it was closing in. Its velocity, nearly 3 arcseconds per hour, was a statistical scream. No asteroid, no comet belonging to our Sun should be moving like that at that distance. The system's algorithms, cold and logical, began their work. They traced the object's path, calculating its orbital parameters, and then came the number that changed everything. The object's eccentricity, a measure of how much an orbit deviates from a perfect circle, was greater than 1. For an astronomer, the single digit is a cosmic fingerprint. An eccentricity of 0 is a circle. An eccentricity between 0 and 1 is an ellipse, the graceful repeating path of every planet, asteroid, and comet bound by our Sun's gravity. But an eccentricity greater than 1 is the mathematical signature of a stranger. It is a hyperbola, the path of a wanderer on a one-way trip, an object moving so fast that our Sun's gravity is merely a temporary host, unable to capture it. This was not a piece of our solar system. This was something from the interstellar dark. Within 6 hours, the alarm bells were ringing across the globe. Confirmation blazed in from 2 other robotic sentinels: the Pan-STARRS Observatory, perched on a volcano in Hawaii, and the Zwicky Transient Facility in California. 3 independent sets of eyes, separated by thousands of miles, had all seen the same ghost. It was real, it was fast, and its trajectory was impossible for any native of our solar system. The possibility of a glitch, a cosmic ray hitting a sensor, a simple error, evaporated. The world's official clearinghouse for such discoveries, the Minor Planet Center in Cambridge, Massachusetts, crunched the numbers from the 3 observatories. Their computers confirmed the terrifying and exhilarating truth. The object's eccentricity was a staggering 1.47, and it possessed a hyperbolic excess velocity of approximately 15 kilometers per second. That was its cruising speed, the velocity it would retain long after it had flung itself past our Sun and returned to the galactic wilderness. This was an interstellar visitor, following a path that would carry it through the heart of our home and then cast it back out into the void. Following astronomical tradition, it was given a designation, 3I Atlas. The 3I identified it as the 3rd confirmed interstellar object in human history. The Atlas suffix honored the tireless Chilean guardian that had spotted it first. But as the world's most powerful telescope swiveled to stare at this new arrival, a chilling realization began to dawn. 3I Atlas was nothing like its predecessors. The first visitor, Y Oumuamua, discovered in 2017, had been a puzzle box. A dark, reddish, tumbling object shaped something like a giant cosmic cigar, it had baffled scientists. It reflected sunlight strangely, and most unnervingly, it exhibited non-gravitational acceleration. It was being pushed by something other than the Sun's gravity, a tiny, persistent nudge that could not be explained. Some scientists, like Marco Micheli and his team, suggested it was outgassing from a comet-like body, even though no visible tail or coma was ever seen. Others, more daringly, whispered that its strange characteristics were consistent with a piece of alien technology, a solar sail, perhaps. Oumuamua was a mystery that had left a permanent question mark hanging in the sky. The second visitor, 2I Borisov in 2019, was a comfort. It behaved exactly as a comet from another star system should. It had a fuzzy coma and a beautiful, distinct tail. It followed the laws of physics to the letter. Borisov was a reassurance, a sign that the universe, while vast, was mostly predictable. 3-Thule Atlas was neither a puzzle box nor a comfort. It was an alarm. Early observations of its light curve, the way its brightness varied over time, delivered the first shock. Most asteroids tumble chaotically, a legacy of ancient violent collisions that sent them spinning like broken toys. Their brightness flickers unpredictably as different. Jagged faces catch the sunlight. But 3I Atlas was different. It showed a quasi-periodic modulation, a regular rhythmic pulse of light. Its brightness rose and fell with a primary period of approximately 7.3 hours. It wasn't tumbling, it was rotating, with a stability that felt controlled, almost mechanical. Embedded within that primary rhythm were smaller secondary oscillations, hinting at a complex geometry or detailed surface features. For weeks, astronomers watched, and the period remained stubbornly, unnaturally stable. Natural objects don't do that. Their spin evolves under the subtle tug of solar radiation and gravitational forces. This object's rotation was as steady as a managed machine. Then came the spectroscopy from the European Southern Observatory's Very Large Telescope. An analysis of the light reflected from its surface revealed more puzzles. As it neared the Sun, any icy comet should have begun to outgas, creating a telltale spectral signature of sublimating water, carbon monoxide, and other volatiles. But 3I's spectrum was eerily clean. It was dominated by reflected sunlight, with only the faintest trace of gas. The color of that reflected light was also wrong. It didn't match any known class of asteroid. It was too red for a typical rocky body, but didn't fit the profile of an organic-rich object either. Strange absorption features in the spectrum hinted at a surface made of materials that were either exceptionally rare in nature or, chillingly, artificially processed. Exotic carbon compounds, metallic films. The data was a riddle wrapped in an enigma. Next, the radio astronomers at Goldstone took their turn. They painted the object with their powerful planetary radar system, firing intense pulses at 8.56 gigahertz and listening for the echo. A normal asteroid, with its irregular cratered surface, returns a rough, scattered echo. 3I Atlas did not. The return signal was weak, but what it showed was stunning. It produced specular reflections, flat, mirror-like returns. This suggested the object possessed large, smooth surfaces oriented at precise angles, like the facets of a cut gem or the panels of a machine. When the James Webb Space Telescope, humanity's magnificent new eye in the sky, turned its infrared gaze toward the visitor, the data became even stranger. JWST's unparalleled sensitivity revealed that the object had a low albedo. It was dark, absorbing most of the sunlight that struck it, but within that faint thermal glow were bizarre, high-intensity spikes of reflected infrared light. These were narrow beams that flashed and disappeared as the object rotated, consistent with thin-film structures or engineered coatings designed to reflect specific wavelengths of light while absorbing others. Nature rarely, if ever, creates materials with such selective and sophisticated optical properties. For 2 weeks, the scientific community buzzed with a mixture of intense excitement and carefully managed dread. Press releases were cautiously worded, emphasizing the object's interstellar origin and its unusual properties, but studiously avoiding any public speculation about what it might be. They had learned their lesson from the media frenzy around Oumuamua. This time, they would be rigorous, careful, and methodical. But then, on the 15th of July, 2025, 2 weeks to the day after its discovery, the time for caution ended. From across the globe, it happened almost simultaneously. The Very Large Array in the New Mexico desert, the Green Bank Telescope in the radio-quiet hills of West Virginia, and the colossal FAST dish in China, 3 of the most sensitive radio observatories on the planet, detected it. A faint, pure, narrowband carrier signal, a single, clean tone, apparently coming from the direction of 3I Atlas. The frequency was approximately 1,820.4 megahertz. Just a whisper away from the sacred hydrogen line, the universe's own dial tone, the very frequency that humanity had long believed would be the channel for any intelligent interstellar call. Radio frequency interference is the constant enemy of the radio astronomer. A stray satellite signal, a faulty microwave oven, a ham radio operator, all can create false positives. But this signal passed every single test for an extraterrestrial origin. It appeared only when the giant dishes were pointed directly at 3I Atlas. Its frequency Doppler shifted in perfect sync with the object's known velocity, proving the signal was moving with the object, not coming from some fixed point in the background sky. Its intensity and frequency were stable across hours of observation. The signal itself was, at first, unmodulated. It carried no obvious information. It was just a pure, unwavering tone, a single sustained note hanging in the void. But its existence was everything. Its frequency stability was extraordinary, suggesting it was produced by a highly sophisticated oscillator, something locked to an atomic standard of precision. Natural phenomena, pulsars, masers, plasma interactions, can sometimes produce narrowband radio emissions, but a signal this clean, this stable, and this close to the hydrogen line was deeply, profoundly suspicious. It was like finding a perfectly tuned flute playing a single, clear C-sharp in the middle of a raging, chaotic thunderstorm. As confirmations poured in from observatories around the world, the cautious skepticism in the scientific community began to dissolve into a terrifying, thrilling, and world-altering possibility. This wasn't a natural emission. This wasn't a coincidence. 3I Atlas was broadcasting, intentionally. Despite the best efforts of space agencies to control the narrative, news of this magnitude could not be contained. Within hours, it had leaked. Social media erupted. The hashtag Nadinak the Reply began trending worldwide. YouTube channels exploded with videos breathlessly proclaiming, "Proof! Aliens answer our call." The object that astronomers formally called 3I Atlas was given a dozen new, unofficial names by a public suddenly captivated by the visitor in their midst. The messenger, the visitor, the reply. Humanity had been shouting into the dark for a century. We had filled the void with our questions, our stories, our noise, and now, from the silent darkness, something had finally, unmistakably, called back. For a few days in the middle of July 2025, humanity was united in a singular, breathtaking focus. Every eye, every instrument, every hope, and every fear was directed at a single, impossibly distant point of light. 3. Atlas. It was a planet-wide vigil, a species holding its collective breath, listening to the faint, pure tone being broadcast from the interstellar void. We were no longer alone, and that stunning, terrifying fact was a fire that burned away the trivialities of daily life. For a brief, shining moment, there were no nations, no politics, no divisions, only a single awestruck family of beings staring up at the sky, listening to a visitor at the door. We were so focused on that first impossible messenger that we almost missed the second, and the third, and the wave that followed. The first hint that 3I Atlas was not a solitary traveler came on July 22nd, just 1 week after its signal was confirmed. The Catalina Sky Survey, another automated sentinel keeping its tireless watch from the mountains of Arizona, flagged a new object. It was fast, its trajectory was hyperbolic, and it was on a path that would bring it through the inner solar system. It was designated 4I. 2 days later, the linear program, Lincoln Near-Earth Asteroid Research, detected another. 5I. The initial reaction was one of stunned disbelief. The scientific community had spent decades arguing that interstellar objects would be vanishingly rare, perhaps one passing through our system every century. To have 3 confirmed in less than a decade was already a statistical marvel. To have 3 arrive within the same month was impossible. It broke every model, every prediction. Then the impossible became the undeniable. As the major observatories trained their instruments on these new arrivals, a new wave of discovery began, this time not from the giant, state-funded machines, but from the backyards and rooftops of ordinary people. A global network of passionate amateur astronomers, armed with powerful telescopes and sophisticated digital cameras, began scanning the skies with a fervor born of historic purpose. Their discoveries, initially flagged on community forums and online message boards, were quickly verified by professional institutions. A high school teacher in Japan, a retired engineer in Brazil, an IT consultant in rural Canada. The catalog of interstellar visitors began to grow, populated by objects designated 6I, 7I, and beyond. This was no longer a scientific event. It had become a human one. A trickle of anomalies had become a steady, inexorable stream, and as the data on these new objects poured in, a chilling, beautiful, and deeply unsettling pattern began to emerge. These were not random pieces of cosmic debris, scattered by some distant, ancient catastrophe. Their arrival was coordinated with a precision that felt less like physics and more like an opening gambit in a game of cosmic chess. The science detective story had begun, and the universe was leaving a trail of clues that pointed toward a single, staggering conclusion. The first clue was their point of origin. When you are a wanderer drifting through the galaxy, your path is shaped by the gravitational whims of countless stars and nebulae. Statistically, interstellar objects should arrive at our solar system from completely random directions, like raindrops falling on a vast field. But these visitors were not random. Dr. Alan Fitzsimmons, an astronomer at Queen's University Belfast, led an international team that mapped the approach vectors of every confirmed object. The result was a map that made the hair on the back of your neck stand up. The objects were all arriving from a narrow cone of the sky, a region just 15 degrees wide, centered on the brilliant blue-white star Vega, in the constellation of Lyra. It was as if they had all been launched from the same place, aimed from the same celestial cannon. Dr. Fitzsimmons and his team ran the calculations. The probability of such a tight grouping occurring by pure chance was approximately 1 in 50 million. In any other field of science, a statistical significance that high is not just evidence, it is proof. The universe was not throwing rocks at us. Something or someone was. The second clue was their destination. Not only were they coming from the same place, they were all going to the same place. Their perihelia, their points of closest approach to our Sun, were all clustered within an incredibly narrow range of distances, between 0.8 and 1.2 astronomical units. 1 astronomical unit, or AU, is the distance from the Earth to the Sun. This meant that every single visitor was flying through a very specific band of space. Earth S orbital zone. They were threading the needle. They were flying through the thin, habitable ring around our star where our own world travels. The odds of a natural object flung randomly from another star happening to pass through this precise region were, in the dry language of the official paper, vanishingly small. These visitors weren't just passing through the solar system. They were buzzing the tower. Their trajectory seemed deliberately calculated to maximize their visibility from Earth-based telescopes while maintaining a safe, respectful distance from our planet itself. The third clue was their impossible shapes. If 3I Atlas had been strange, a thin panel rotating with mechanical precision, the new arrivals were a veritable gallery of cosmic surrealism. Light curve analysis of 4I revealed it to be a needle-like object with an aspect ratio approaching 20:1, longer and thinner than any known natural object. It was tumbling end over end every 3.2 hours, but again, the motion wasn't the chaotic wobble of a collision fragment. It was a controlled, stable rotation, as if internal mechanisms were managing its orientation, perhaps to optimize solar energy collection or maintain a communications link. Vis-a-vis I looked like a tumbling shard of mirrored glass, its light curve showing complex, sharp variations that suggested a partially fragmented but still coherent structure. Spectroscopically, it hinted at being porous or even partially hollow. 6I, the object found by the Canadian IT consultant, was the most bizarre of all. Its light curve was consistent with what astronomers, for lack of a better term, could only describe as a flake. Something impossibly thin and flexible, its brightness fluctuating in a way that suggested it was rippling, deforming as it flew through space, perhaps under the gentle pressure of sunlight. These were not shapes that nature makes. Physics and gravity conspire to break down rocky bodies into roughly spherical chunks. Icy comets fracture along lines of structural weakness. But needles, shards, rippling, sheet-like structures? These were the shapes of engineered objects. They were the shapes of things designed for a purpose, optimized for interstellar travel with minimal mass and maximum surface area. The exact characteristics one would expect from solar sails, communication relays, or sensor probes. The final and most damning clue was the chorus of their voices. As radio telescopes around the world began to track each new object, they found that every single one was broadcasting. Each produced its own faint narrowband radio emission near the hallowed hydrogen line. This fact alone annihilated any lingering theory of a bizarre but natural phenomenon. A single object producing such a signal could be a freak of cosmic plasma physics. But a dozen, all arriving together, impossible. And they weren't all singing the same song. It was a distributed, coordinated communication system. 3I Atlas, the first messenger, maintained its steady, unmodulated carrier tone, a pure note that now seemed like a simple, attention-grabbing hail. 4I, the cosmic needle, broadcast at a slightly different frequency, 1420.6 MHz, and its signal carried a subtle, rhythmic amplitude modulation, a gentle pulse. 5I, the shard, transmitted in brief, powerful bursts across several different frequencies within the waterhole spectrum. And 6I, the flake, was producing the most complex signals of all, patterns that seemed to carry encoded information in both their frequency and their timing. This was not a random set of emissions. This was a fleet, a coordinated flotilla of messengers, each playing a different instrument, but all contributing to a larger, more complex symphony of communication. It was Dr. Elena Vasquez, a brilliant radio astronomer at the Arecibo Observatory's successor facility, who put all the pieces together into what became known as the staging hypothesis. She argued that what we were witnessing was not an arrival, but a carefully orchestrated performance. If you wanted to make contact with a newly discovered technological civilization, a species you knew was prone to skepticism and fear, you wouldn't just send a single message. You would send a dozen. You would design them to be different, each one providing a unique and irrefutable piece of the puzzle, making it increasingly difficult to dismiss the entire event as a natural anomaly. You would provide multiple redundant lines of evidence, statistical, physical, and electromagnetic. It was a rigorously engineered approach to saying hello. But it was the final layer of the analysis that transformed the mystery from a scientific puzzle into a deeply personal human story. Astronomers began to trace the visitors' journeys backward. Assuming they were traveling at plausible interstellar speeds, somewhere between 10% and 20% the speed of light, they could calculate when each object must have been launched from its home system, roughly 50 to 100 light-years away. When they cross-referenced those launch dates with Earth's own broadcast history, a timeline emerged that was too precise to be a coincidence. The launch window for 3I Atlas corresponded to a departure around 1975. This was the peak era of Earth's most powerful television transmitters and the first major planetary radar campaigns, the very time our radio bubble was at its brightest and most powerful. The launch window for 4I aligned with the early space age, the 1960s, when powerful military early warning radar installations began painting the skies with signals strong enough to cross interstellar distances. The launch window for 5I corresponded to the 1980s and 90s, the period when commercial satellite communications began to fill Earth's spectrum, with a dense web of structured artificial signals. It was as if someone had been listening to our civilization's growing radio signature for decades and had been dispatching a new probe in response to each successive chapter of our technological story. They hadn't just heard us. They had been monitoring us, studying our development. They knew our history, written in the ghostly language of radio waves. The visitors weren't just acknowledging our call. They were showing us our own reflection in a mirror held up across the void of space and time. They were letting us know, with terrifying and beautiful precision, that they had been listening all along. The numbers were there, buried in the noise of the cosmos, waiting for a mind sharp enough to see the pattern. And the pattern they revealed was a story. Our story, told back to us by a silent, patient observer across an ocean of stars. The idea that this flotilla of visitors was a direct response to our own broadcasts was no longer a fringe theory. It was the central, unavoidable hypothesis, and proving it became the most urgent scientific quest in human history. But this was a detective story where the crime scene was the entire solar system. The clues were written in the arcane language of orbital mechanics and information theory, and the suspect was an intelligence whose capabilities we could barely begin to fathom. The daunting task of reconstructing humanity's electromagnetic history fell to Dr. James Chen and his team at MIT's Haystack Radio Observatory. They weren't just astronomers. They were cosmic archaeologists, digging through the fossil record of our own radio emissions. Their work was a painstaking reconstruction of our expanding radio bubble, decade by painful decade. It was one thing to say we'd been broadcasting for a century. It was another thing entirely to calculate which of those broadcasts could have actually been heard 50 light-years away. They started in the 1940s with the birth of television. The signals were weak, unfocused, and would have been swallowed by cosmic static within a few light-years. An alien civilization listening to those would have needed a telescope the size of a planet to pick them out. But then came the Cold War. The 1950s and 60s saw the proliferation of massive, high-power military radar systems, the Ballistic Missile Early Warning System, BMEWs, for instance. These were the first signals powerful enough to have a real chance of being detected across interstellar distances. Their narrow, sweeping beams were like searchlights cutting through the fog, painting the sky with a signature of anxious, terrestrial power. The true turning point, however, came in 1963 with the completion of the Arecibo Observatory. That magnificent 305-meter dish wasn't just a listening device, it was the most powerful voice humanity had ever possessed. When used for planetary radar, to map the shrouded surface of Venus or to track a near-Earth asteroid, Arecibo was capable of transmitting a 1,000,000-watt beam of tightly focused radio energy. In those moments, it was a beacon. Any civilization with technology comparable to our own, sitting in the path of that beam, would have received a signal so powerful, and so obviously artificial that it would have been undeniable proof of our existence. The timeline became a sobering and precise calendar of our cosmic visibility. Any civilization within 50 light-years of Earth would have begun receiving our faint television signals in the late 1970s and 1980s. Our more powerful military radar transmissions would have arrived in the 1990s and 2000s, providing clearer, stronger evidence of a technological society. The brilliant, piercing flashes from Arecibo's planetary radar would have been the exclamation points, the undeniable confirmation. But were the visitors simply a generalized response to this growing noise, or was it more specific? This question led to the next phase of the investigation. A team led by Dr. Sarah Martinez at the Harvard-Smithsonian Center for Astrophysics began a monumental task of cross-referencing. They took the calculated origin vectors of each interstellar visitor, that narrow cone pointing back toward Lyra, and traced them backward through galactic space. Then they cross-referenced those paths with the history of Earth's most powerful transmissions. They weren't just looking for a general correlation, they were looking for a geometric bullseye. Using complex Monte Carlo simulations to rule out random chance, they discovered alignments that were too perfect to be coincidental. One star system, HD 164595, a Sun-like star 94 light-years away, sat directly in the path of Arecibo's most powerful transmissions during the 1970s and 1980s. The geometry was flawless. When Arecibo was pointed at Venus for its radar mapping campaigns, its beam swept across the precise position of HD 164595 in the sky. It was like being caught in the sweep of a lighthouse beam. For any receivers in that system, Earth's signal would have been a recurring, brilliant flash of artificiality. Another target was Wolf 359, a dim red dwarf star much closer, only 7.9 light-years away. Due to its position nearly perpendicular to Earth's equatorial plane, it would have received our commercial television and FM radio broadcasts with unusual clarity. From its vantage point, it saw Earth from the top down, maximizing its exposure to the signals that radiate most strongly from our planet's most populated latitudes. And then there was Tau Ceti, a star only 12 light-years distant, long a favorite target for SETI searches because of its similarity to our Sun. The analysis showed that Tau Ceti had been perfectly aligned with several major planetary radar campaigns in the 1990s and early 2000s. It would have received clear, unambiguous evidence of our technological activity precisely during the period when we were taking our own first bold steps into exploring our solar system. The statistical analysis concluded that the correlation between the visitor's origins and these geometric alignments was significant at the 4 sigma level. In layman's terms, that meant there was only about a 1 in 15,000 chance that the patterns were a fluke. In the world of particle physics, a 5 sigma result is the gold standard for a new discovery. 4 sigma wasn't absolute proof, but it was a result so strong that it demanded the world's most serious consideration. Of course, the scientific world is built on skepticism. A counter-argument, led by Dr. Robert Hayes at the University of Arizona, quickly emerged. Hayes and his team argued that the analysis was falling prey to what statisticians call the look elsewhere effect. If you search through enough data with enough variables, hundreds of nearby stars, decades of transmission history, you are bound to find apparent patterns, just as you can find familiar shapes in the random arrangement of clouds. They conducted their own parallel analyses using randomized data and showed that spurious correlations could indeed emerge from chance. We're seeing patterns because we are exquisitely evolved, pattern-seeking animals, Hayes wrote in a widely cited, blistering critique. The universe is under no obligation to be interested in our old episodes of I Love Lucy. The debate raged in academic journals and scientific conferences. It was a classic battle between a revolutionary new idea and the rigorous conservatism of the scientific method. But then came the evidence that tipped the scales. It came not from geometry, but from time. Dr. Lisa Johansson at the SETI Institute developed what she called the echo hypothesis. Her model was simple in its premise but profound in its implications. If each visitor was a direct response, an echo, to a specific era of our broadcasts, then their arrival time should mirror our own transmission history, with a delay accounted for by the round-trip travel time of light and the physical travel time of the probe. Assuming the probes traveled at a brisk but plausible 10 to 20% of light speed, she constructed a mathematical model that predicted when each visitor should have arrived, based on the timing and intensity of Earth's most powerful radio transmissions. The results were stunning. She plugged in the peak of powerful television broadcasting in the 1970s, and the model predicted an arrival time that matched almost to the month the appearance of 3I Atlas. She input the deployment of major military radar systems, and the model spat out the arrival window of 4I, the rise of commercial satellite communications, the arrival of 5I. The agreement between her predictions and the observed reality was too remarkable to be dismissed as coincidence. It was as if she had found a Rosetta Stone that translated our history into their itinerary. This was more than just circumstantial evidence. This was a specific, testable prediction that had been confirmed. The visitors weren't just coming from the right places, They were arriving at the right times. But the final irrefutable proof, the smoking gun of the cosmic crime scene, came from the signals themselves. As the decryption teams analyzed the complex radio emissions from the later arrivals, they found something that sent a shockwave through the global scientific community. Several of the objects were broadcasting patterns that appeared to be a direct, modified reply to the 1974 Arecibo message. That famous 3-minute broadcast had been a masterclass in concise communication. It had encoded the numbers 1 through 10, the atomic numbers for the elements of life, a diagram of DNA, a human figure, and a map of our solar system. It was humanity's most deliberate attempt to say, "This is who we are, and this is the science we know." Now, across 50 light-years of space, that message had been answered. Some of the visitors' signals contained similar numerical progressions, but with intentional, clever variations. They would broadcast the binary sequence for the numbers 1 through 10, just as we had, but then they would continue extending the sequence to include mathematical concepts we had discovered but never broadcast, like the value of pi or Euler's number. The most striking part was the prime numbers. The Arecibo message had used the product of 2 primes, 23 and 73, as its structural foundation, a universal mathematical handshake. Now, several of the visitors were broadcasting their own sequences of primes, 2, 3, 5, 7, 11, 13, and so on. But then their sequences would deviate from the standard progression in deliberate, patterned ways. They were broadcasting sequences of twin primes, Sophie-Germain primes, and Mersenne primes, advanced concepts from number theory that human mathematicians had spent centuries uncovering. It was an unmistakable, breathtakingly intelligent statement. It was as if they were saying, "We received your simple introductory message. We understood your use of prime numbers as a sign of intelligence. Now, let us show you what we know. Let us show you the music of mathematics as we understand it." Even with the most rigorous statistical safeguards in place, pre-registered hypotheses, Monte Carlo simulations to test for random patterns, the connection remained robust. The probability that random cosmic noise could contain such sophisticated mathematical sequences, directly referencing humanity's own single, focused broadcast, was less than 1 in 10,000. The skeptics could no longer dismiss the evidence as pattern-seeking. The geometric alignments, the temporal echoes, and now the mathematical reply, taken together, they formed an undeniable interlocking case. The visitors had not just heard our noise. They had listened. They had parsed our signals, understood our science, and were now demonstrating, with overwhelming clarity, that they knew we were here. They had heard us specifically. And after a half-century of patient travel, their reply had finally arrived. By October of 2025, the initial shock had begun to recede, replaced by a focused, obsessive, and almost frantic scientific inquiry. The question was no longer if we were being contacted, but how. The flotilla of visitors was a complex, multi-layered message, but 3i Atlas, the first to arrive and the anchor of their communication network, remained the primary subject of investigation. It was the Rosetta Stone, the key to understanding the intelligence on the other end of the line. Dozens of observatories, coordinated in a global effort of unprecedented scale, had compiled the most detailed profile of an interstellar object in history, and the picture that emerged was of a machine, an elegant, enigmatic, and deeply alien piece of technology. Its physical dimensions alone were a profound statement. 3i Atlas measured approximately 200 meters in its longest dimension, but was only about 20 meters wide. Radar observations capable of piercing any potential dust cloud suggested its thickness was less than 2 meters. This gave it an extreme aspect ratio of more than 10 to 1, making it more akin to a plank or a massive, flattened needle than any natural asteroid. It was a shape optimized not for durability against cosmic collisions, but for something else entirely. Perhaps for catching the faint pressure of starlight, or for maximizing surface area for communication or energy collection. It was a shape born of engineering, not geology. Then there were the accelerations. The tiny, non-gravitational pushes that had so mystified astronomers studying Oumuamua were present here too, but with a crucial difference. They were not random. As 3I Atlas swept closer to the Sun, its trajectory deviated from a purely gravitational path with a subtle but unmistakable precision. The pushes were always coherent, directed either perfectly toward the Sun or perfectly away from it. This was not the chaotic, unpredictable outgassing of a tumbling comet. This was controlled. The accelerations perfectly matched the mathematical predictions for radiation pressure, the gentle, persistent push exerted by sunlight itself. A solar sail. But there was a paradox. For a solar sail to work, it needs to be highly reflective, like a mirror, to catch and bounce photons effectively. Yet the spectroscopic data and the infrared observations from the James Webb Space Telescope showed that 3I Atlas had a low albedo. It was dark, absorbing most of the light that hit it. How could a dark object be propelled by light? The answer hinted at a level of material science far beyond our own. It suggested a surface made of a metamaterial, an engineered substance with properties not found in nature. Perhaps it was a surface that could be tuned, changing its reflectivity or emissivity in real time, absorbing energy when it needed to power its systems and becoming reflective when it needed to adjust its course. This theory was bolstered by its bizarre thermal behavior. As it moved through the solar system, its temperature did not follow the simple inverse square law that governs the heating and cooling of every other rock and planet. Instead, it exhibited thermal plateaus, long periods where its surface temperature remained almost constant, despite the rapidly changing distance from the Sun. It was actively managing its own heat, shunting it, storing it, or radiating it away with an efficiency that defied natural explanation. It was behaving like a meticulously designed spacecraft, not a passive chunk of rock. Its rotation was just as controlled. Unlike the wild, chaotic tumbles of natural asteroids, 3I Atlas maintained a stable, almost regal spin. Its axis of rotation was precisely aligned not with its own trajectory, but with specific celestial coordinates, pointing toward a fixed spot in the distant star field. More intriguingly, as its angle to the Sun changed, its rotation period would subtly, almost imperceptibly, alter. It was as if the object was making tiny attitude adjustments, tilting itself to optimize its exposure to the Sun, much like a sunflower turns its face to follow the light. And then there was the signal. The pure, unwavering carrier tone at 1420.4 MHz was just the beginning. The decryption teams discovered that the primary signal was accompanied by a series of harmonics, fainter, secondary signals at precise mathematical integer multiples of the primary frequency. This was a classic sign of an engineered broadcast, a way of embedding redundant information and proving that the signal was not a natural fluke. For weeks, the signal had remained unmodulated, a single, sustained note. But as 3I Atlas approached its perihelion in November, that changed. The pure tone gave way to a pattern, a simple, beautiful, and undeniably intelligent one. The signal began to pulse. The pulses came in distinct groups, separated by pauses. A group of 2 pulses. Pause. A group of 3. Pause. 5 pulses. Pause. 7, 11, 13, 19. It was broadcasting the prime number sequence, the universal mathematical greeting that Carl Sagan and Frank Drake had dreamed of decades before. It was the kind of signal that SETI researchers had long held up as the ideal first contact communication, mathematically sophisticated enough to prove intelligence, but simple enough to be decoded by any species that understood the basic concept of counting. The mainstream astronomical community, steeped in a tradition of caution, still tried to find a natural explanation. The Hubble Space Telescope captured images showing a faint, diffuse coma of gas and dust surrounding 3I Atlas, consistent with the outgassing of a comet. The Astronomical Picture of the Day website, a popular NASA portal, featured these images with captions emphasizing normal cometary behavior. Ground-based telescopes detected the spectral signatures of water vapor and carbon monoxide in the object's immediate vicinity. For the hardened skeptics, this was enough. "It's a comet," they declared. "An unusual one, to be sure, but a comet nonetheless." But the cometary explanation couldn't account for all the facts. The outgassing was far too weak to explain the powerful and controlled non-gravitational accelerations. The coma itself was asymmetric, suggesting the gas was being vented from specific points in a controlled manner, rather than sublimating evenly from a rotating nucleus. And most damningly, the prime number radio broadcast continued, steady and strong, even when the object was at its farthest point from the sun, where the cold of deep space should have frozen any cometary activity solid. The debate crystallized into two competing camps. On one side were the naturalists, who proposed ever more exotic, but still plausible, natural scenarios. Perhaps it was a fragment of a planet that had been destroyed, composed of strange metallic ores that could interact with the solar wind to produce radio emissions. Perhaps its controlled rotation was a gyroscopic effect caused by a hollow internal structure. On the other side were the artificialists who argued that the simplest explanation, the one that fit all the available data, was that it was an artificial probe, an autonomous messenger system, powered by solar energy, using a solar sail for navigation and broadcasting a deliberate signal. A third, more unsettling hypothesis began to emerge from the fringes, proposed by Dr. Elena Rodriguez at the University of Barcelona. She suggested that 3I Atlas might not fit neatly into the categories of natural or artificial, but could be something in between. Technobiotic debris. Perhaps it was the remnant of a civilization that had mastered biological engineering, creating semi-living materials that could self-repair and maintain their structure across interstellar voyages. The object might be, in some fundamental way, partially alive. As 3I Atlas neared its closest approach to Earth in late November, a flyby at a comfortable distance of 0.3 astronomical units, about 45 million kilometers, the conversation shifted from scientific debate to practical risk assessment. The Planetary Defense Coordination Office, a NASA department created to protect Earth from asteroid impacts, found itself in an unprecedented position. How do you assess the threat level of an object that can think? The controlled accelerations proved it could maneuver. The question was whether those maneuvers were pre-programmed, automatic responses, or if they represented active, real-time guidance by an onboard intelligence. Adding another layer of mind-bending complexity were the companions. High-resolution imaging revealed several smaller objects, designated 3I Atlas A through F, traveling in a loose but stable formation with the primary object. These fragments, if that's what they were, exhibited similar radio emissions and appeared to make tiny, coordinated course corrections. Were they calibration targets, relay nodes for a distributed communication system, or autonomous sub-probes waiting to be deployed? The energy calculations alone were sobering. To broadcast its signal with such clarity across millions of kilometers required kilowatts of power, a substantial output for a dark object with a limited surface area for solar collection. If the emissions were intentional communications, they represented a significant and continuous expenditure of energy. Someone, or something, was spending a great deal of its precious power budget to make absolutely sure we could hear them. On November 28, 2025, 3I Atlas reached perihelion, its closest point to the Sun. This was the moment of maximum solar heating, maximum gravitational stress, and if the object was indeed a piece of technology, perhaps the moment of maximum activity. Every major observatory on Earth was watching. Every radio dish was listening. The astronomical community, and by now the entire world, held its collective breath. Humanity's most enigmatic visitor was about to fly through the crucible of our solar system. We were all waiting to see what secrets it would reveal about itself when it passed through the fire. The moment the pulses began, the simple, stark, elegant broadcast of prime numbers, the world changed. The debate over whether Three-Eye Atlas was natural or artificial evaporated in an instant, replaced by a question humanity had only ever explored in the realms of fiction. A question so profound and so terrifyingly real, it sent a tremor through the foundations of global power. What do we say back? For decades, a small dedicated group of scientists and thinkers under the umbrella of the International Academy of Astronautics had quietly worked on this very problem. They had developed post-detection protocols, a careful, sober set of guidelines for what to do in the event of a confirmed SETI signal. The protocols were a testament to academic foresight, covering everything from verification and analysis to the political and social ramifications of an announcement. But they were, at their core, advisory. They were a gentleman's agreement, a theoretical framework built on the assumption that any first signal would be a faint, distant whisper from a far-off star, giving humanity years, if not centuries, to formulate a reply. No treaty, no protocol, no dusty academic paper had ever anticipated this. They had not anticipated a visitor in our own backyard. They had not anticipated a flotilla of messengers that could maneuver, and they had certainly not anticipated a clear, active, and ongoing broadcast that demanded an immediate response. The theoretical had become brutally, terrifyingly practical. The United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, convened an emergency session in Vienna. For 60 years, this committee had been the world's forum for space policy, dealing with the mundane realities of space debris, satellite orbits, and commercial launch regulations. Suddenly, its delegates found themselves thrust into the role of interstellar diplomats, grappling with a situation for which there was no precedent in human history. The Committee on Space Research, IOSPAR, weighed in with its own concerns. Their planetary protection protocols were designed to prevent earthly microbes from contaminating Mars or Europa, and to prevent alien microbes from contaminating Earth. But did those principles apply to a 200-meter-long, potentially intelligent artificial object? Was it a biological risk, a technological risk, or something else entirely? The most immediate and chaotic problem fell to the International Telecommunication Union, ITU. The world's radio frequencies are a finite, precious resource, and the ITU is the global traffic cop that allocates frequency bands to prevent interference between cell phones, satellites, and television stations. The visitors were broadcasting in a band nominally protected for radio astronomy. But what happened now? Did their transmissions have rights? What if our own reply interfered with their ongoing signals? The ITU-S role suddenly shifted from managing human noise to presiding over humanity. S first conversation with the cosmos. Behind the closed doors of government buildings in Washington, Beijing, Brussels, and Moscow, the debate was less about philosophy and more about power. The national space agencies, NASA, ESA, Roscosmos, and the rapidly ascending CNSA in China, all understood the stakes. The first nation to successfully establish a two-way conversation with this intelligence might gain an unimaginable advantage. It wasn't just about scientific prestige, it was about the potential for knowledge and technology that could redefine the global balance of power for 1,000 years. NASA's Deep Space Network, with its massive dishes in California, Spain, and Australia, had the existing hardware to transmit a signal powerful enough to reach 3E Atlas. The European Space Agency's ESTRAC network had similar capabilities. China's own deep space communication infrastructure, a source of immense national pride, was quickly approaching parity. The technical ability to reply was not in question, but the most powerful transmitters on the planet, the ones capable of the most focused, high-energy beams, belonged to military organizations and academic institutions, creating a complex web of authority and control. Into this crucible of uncertainty stepped an unlikely and unassuming leader, Dr. Jill Tarter. A legendary figure in the SETI community, she had dedicated her life to the search for extraterrestrial signals, facing decades of ridicule and funding cuts with unwavering scientific resolve. Now, in her 70s, with her official titles long since retired, her decades of quiet, tireless work had given her a unique moral authority. She became the de facto coordinator of the scientific response, her calm, rational voice cutting through the rising tide of political posturing and public panic. In a series of emergency video conferences that connected the world's leading astronomers and space agency heads, she laid out the choice before them. "We have always known this moment might come," she said, her voice steady and clear. "The only question now is whether we respond as one species or as a squabbling collection of competing nations." Her plea for unity resonated. The technical challenges alone were too immense for any one nation to solve on the compressed timeline. Any reply to 3I Atlas would have to be a masterpiece of celestial mechanics and radio engineering. The object was a moving target, its distance and velocity changing by the second. A successful transmission would require a constant, real-time recalculation of the Doppler shift, precisely adjusting the frequency of the outgoing signal so that it would arrive at the object's receiver perfectly in tune. The signal itself would need to be powerful enough to be heard clearly above the sun's radio noise, yet narrowband enough to be instantly recognizable as artificial. A consensus on the content and structure of the reply began to emerge, guided by the traditions of SETI and the fundamental principles of information theory. The protocol was elegant in its logic. First, begin with mathematics, the one truly universal language. The visitors had hailed us with prime numbers. We would reply in kind, reciprocating their sequence to demonstrate, with perfect clarity, that we had received their message and understood its meaning. It was the cosmic equivalent of a handshake, a simple, unambiguous, "we hear you." Second, introduce more complex concepts, but stick to the fundamentals of science. We would transmit the atomic structures of the first few elements in the periodic table, the physical constants that govern the universe, perhaps even a simple map of our own solar system building on the visual language of the original Arecibo message. The question of what not to say sparked the most heated debate. Military advisors and intelligence agencies issued stark warnings against revealing any sensitive information about Earth's technological capabilities, our infrastructure, or, most critically, our defensive systems. But the scientists, led by Tarter, argued that this was a foolish and paranoid position. Any civilization capable of building and sending a flotilla of autonomous probes across interstellar space would already possess a level of scientific understanding that would make our own technology seem primitive. To them, our most advanced military radar would be as transparent as a glass window. Hiding our secrets would be like a tribe of uncontacted people trying to hide the existence of their spears from a satellite overhead. The compromise was both pragmatic and elegant. We would only transmit information that we had already deliberately broadcast into space, the core mathematical and physical concepts from the 1974 Arecibo message, updated with our current, more precise knowledge. We would reveal nothing new. We would simply confirm what we had already shouted to the heavens. The modulation scheme, the way the information was encoded onto the radio wave, had to be simple enough for any intelligence to decode, yet robust enough to survive the noisy interplanetary environment. The team settled on a slow but incredibly reliable method called pulse position modulation, heavily reinforced with error-correcting codes. And to ensure the message was instantly recognizable, it would be preceded by a preamble of Barker codes, unique mathematical sequences that are statistically almost impossible to generate by natural processes. They were the digital equivalent of a trumpet fanfare announcing the start of a deliberate message. The clock was ticking. 3I Atlas was on a hyperbolic trajectory, and its high velocity meant it would only remain within optimal communication range for a few precious weeks. Earth's own rotation added another constraint, creating brief communication windows as different antenna complexes on the planet rotated into view of the object. Dynamic scheduling software, originally developed to juggle communications with our own deep space probes like the Mars rovers, was repurposed to maximize every available second of contact time with humanity's first interstellar correspondent. The final decision to transmit was made on December 3, 2025. 3I Atlas was approaching its optimal viewing geometry, and its prime number broadcast was continuing, growing in complexity. It was demonstrating a mathematical sophistication that went far beyond simple counting, as if it were patiently waiting for us to prove we were ready for a more advanced conversation. Under the watchful eyes of an international consortium of scientists and officials, Dr. Sarah Martinez, the same astrophysicist who had first confirmed the geometric alignments, keyed the transmission from the newly christened Arecibo Legacy Array in Puerto Rico. The facility was now under international coordination, a symbol of the global unity Tartar had championed. The message began. A powerful, focused beam of radio energy shot from the dish, carrying a simple, profound sequence of pulses. 2, 3, 5, 7, 11, 13, confirming that we had received and understood. It then transitioned, encoding the first few elements of the periodic table, and concluded with a simple diagram of the hydrogen atom, the very element that defined the frequency of our historic conversation. The transmission lasted only a few minutes. Then, silence. The world waited. The light travel time to 3E Atlas and back was approximately 18 minutes. For 18 agonizing minutes, the planet held its breath. Then, it came. The visitor's signal, which had been broadcasting its steady prime number sequence, changed. The sequence stopped. For a few seconds, there was only the pure carrier tone. And then, a new pattern began. It was a sequence of pulses corresponding to atomic numbers. Hydrogen, helium, lithium, beryllium. It was mirroring our message back to us. But then, after it had reciprocated our list, the sequence diverged. It included pulse groups that didn't match any known element on Earth's periodic table. It was as if the visitor was saying, "Excellent. We understand your chemistry. Now let us show you some of ours." But the most breathtaking moment was not what was heard, but what was seen. At the exact moment our transmission would have reached the object, ground-based optical telescopes detected a subtle, instantaneous brightening, a brief, shutter-like flash, lasting for the precise duration of our broadcast. Photometric analysis suggested that a part of 3I Atlas had physically reconfigured itself, perhaps unfurling reflective panels or changing its orientation to create a visual wink across 45 million kilometers of space. This was no longer a debate. This was not a natural phenomenon. This was active, real-time communication. This was an intelligence that could receive, process, and reply in multiple formats, radio and optical, simultaneously. News of the successful exchange was impossible to contain. Amateur radio operators who had been monitoring the frequencies had recorded the entire exchange. Social media exploded not with speculation, but with pure, unadulterated joy and wonder. Humanity had just held its first conversation with a visitor from another star system. 2 days later, the second exchange occurred. This time, 3I Atlas initiated it. It transmitted a long, complex mathematical sequence. When Earth's mathematicians and cryptographers began to decode it, a wave of awe and humility washed over them. The visitor was describing orbital mechanics, but it wasn't just describing the general theory. It was describing, with exquisite precision, the exact hyperbolic trajectory it was currently following through our solar system. It was showing us that it knew precisely where it was, where it had come from, and where it was going. It was demonstrating, without any room for doubt, that its presence in our solar system was not an accident. The trajectory had been calculated, planned, and executed across interstellar distances with a mastery of physics and engineering that humanity could only dream of. The visitor hadn't just answered our ancient call into the darkness. It was now beginning to explain, with the patient clarity of a master teacher, exactly how it had hurt us and how it had come to find us. The real conversation was only just beginning. The news of the successful two-way exchange with 3i Atlas did not arrive like a gentle dawn. It crashed upon the shores of human consciousness like a tsunami, a silent, planet-wide wave of information that instantly and irrevocably altered the landscape of our reality. The first conversation was over. The second, the one we began to have with ourselves, had just begun, and it was a chaotic, terrified, and exhilarating roar. In the first week after the exchange became public knowledge, mental health hotlines across the world reported a 340% increase in call volume. The conversations, logged by overwhelmed counselors from Sydney to Seattle, followed a strangely consistent pattern. There was the vertiginous, stomach-dropping anxiety of our own cosmic insignificance. There was the profound, almost unbearable excitement of a future suddenly rendered limitless. And then there was a new, peculiar, and deeply human emotion, a kind of retroactive loneliness. It was the sudden, crushing realization that we had spent our entire history believing ourselves to be utterly alone in an empty universe, when in fact a neighbor had been listening just next door. We had been shouting into what we thought was a void, but it had been a quiet, crowded room all along. Dr. Susan Chen, a leading psychiatrist at the Stanford Psychology Institute, quickly gave the phenomenon a name: contact syndrome. The symptoms were as varied as humanity itself. Patients reported intensely vivid dreams of space travel and alien worlds. They described an obsessive sky-watching behavior, a compulsion to simply stand outside at night and stare upwards, as if trying to personally will the visitors into view. Most pervasively, they spoke of a sudden, disorienting shift in perspective, a feeling that their earthly concerns, their mortgages, their careers, their political squabbles, had become instantly and absurdly trivial in the face of this new, cosmic context. It is as if the entire species is simultaneously going through a spiritual awakening and a nervous breakdown, Dr. Chen noted in a preliminary paper that would become the foundational text of a new field of psychology. The world's religions, the traditional arbiters of humanity's place in the cosmos, found themselves in the unprecedented position of having to respond to a revelation that was not written in their sacred texts. The Vatican, with centuries of experience navigating the intersection of faith and science, responded with remarkable speed and grace. Within 48 hours, a formal statement was issued. The discovery of intelligent life beyond Earth, it declared, was entirely consistent with Catholic theology. In a globally televised address from St. Peter's Square, Pope Francis, his voice filled with a genuine sense of wonder, proclaimed, "The universe is a vast and magnificent testament to God's creation. If our Creator, in His infinite love and creativity, has chosen to populate it with other forms of consciousness, this does not diminish our place, but rather magnifies the grandeur of His work." Evangelical Protestant communities were far more fractured. Some celebrated the news as a fulfillment of prophecy, evidence of God's cosmic scope. But for others, it triggered a deep theological crisis. Emergency conferences were convened in seminaries around the world to grapple with questions that had until now been the stuff of late-night dormitory debates. Did beings from other worlds possess souls? Had Christ's sacrifice on the cross extended to non-human species across the galaxy? Was this a divine messenger or a sophisticated deception? Islamic scholars, by contrast, found more comfortable footing, pointing to verses in the Quran that speak of God as the Lord of all worlds. Buddhist leaders spoke of the contact as a beautiful confirmation of the universal nature of consciousness. Hindu traditions, already embracing cosmic scales of time and a multiverse of realms, adapted most easily of all, viewing the visitors as simply another manifestation of the infinite and complex tapestry of existence. While the soul of humanity grappled with the divine, its baser instincts went to work in the financial markets. In what economists would later dub the contact correction, Wall Street experienced a period of volatility that made a mockery of all previous models. On the first day of trading after the news broke, aerospace and defense stocks surged on pure speculation. But the rally was short-lived. When the initial analysis of the visitors' messages showed no signs of hostile intent, defense stocks reversed sharply. Who needed advanced fighter jets when the beings next door could cross 50 light-years of space and communicate with modulated radio waves? The real shift was in commodities. Gold, humanity's ancient safe haven in times of uncertainty, barely budged. Investors intuitively understood that a civilization capable of interstellar travel would have little use for a soft, shiny metal. Instead, the price of rare earth elements, the exotic materials essential for high-tech electronics and magnets, spiked dramatically. Lithium, the key ingredient in our batteries, doubled in price within a week, as speculators gambled that alien technology would be built upon the same fundamental principles of energy storage. The cryptocurrency markets, already a wild west of speculation, became a fascinating real-time display of collective psychology. Bitcoin soared on the theory that a decentralized, purely mathematical currency might be the only kind trusted by an alien intelligence. Dozens of new contact coins were minted overnight, most of them transparent scams, but some representing genuine, if naive, attempts to create communication protocols built on blockchain technology, a universal ledger for interstellar exchange. Simultaneously, an information war erupted across the digital landscape. State-sponsored bot networks, sensing a moment of global uncertainty, flooded social media with competing narratives. Some claimed the entire event was an elaborate global hoax, a Project Blue Beam scenario designed by world governments to usher in a new era of centralized control. Others fanned the flames of fear, insisting the visitors were a silent invasion force, their peaceful messages a deceptive Trojan Horse. The platform moderators at Twitter, Facebook, and TikTok found themselves in the surreal position of having to fact-check claims about alien intelligence. Twitter's policy team, working in a frantic 24/7 war room, developed new guidelines for verified extraterrestrial content. A special verification badge, a small blue planet icon, began to appear next to the accounts of official observatories and space agencies, creating a new and desperately needed category of trusted sources for cosmic news. The tremor rippled outward, changing the very fabric of daily life. Universities reported an unprecedented surge in applications for physics, astronomy, and engineering programs. Community colleges, nimble and responsive, began offering evening crash courses in radio technology and signal processing, teaching ordinary citizens how to build their own receivers to listen in on the interstellar conversation. The art world responded with a burst of creative intensity. Museums hastily organized exhibitions of space-themed art. Composers wrote symphonies based on the prime number sequence. Visual artists created stunning installations using the 1420 MHz hydrogen line frequency as an organizing principle, translating the cosmic dial tone into color, light, and sculptural form. New social rituals emerged organically. Listening parties became a global phenomenon, with groups of friends and neighbors gathering around radios tuned to the hydrogen line. The hashtag #NasherDearVisitor became a planetary message board, with millions of people posting their hopes, fears, and questions into the digital ether. Amateur astronomy clubs were overwhelmed with new members, their star parties drawing crowds of thousands, all hoping to catch a glimpse of the distant points of light through a telescope. The change was even visible from space. For the first time in decades, urban light pollution became a serious political issue. City councils faced immense public pressure to pass dark sky ordinances, dimming streetlights and non-essential lighting to give their citizens a clearer view of the heavens. The psychological impact was profound and deeply personal. People began making life-altering decisions through this new cosmic lens. Marriage proposals were made under the stars, with vows that reference the newfound vastness of the universe. Dating apps added a new field to their matching algorithms. Views on extraterrestrial contact. Corporate marketing, ever adaptive, pivoted with breathtaking speed. Car commercials no longer featured vehicles navigating busy city streets, but families driving out to remote, dark locations to gaze at the sky. Smartphone manufacturers began emphasizing their cameras' low-light astrophotography capabilities. A popular coffee company released a new contact blend, marketed as the perfect companion for a long night of watching and waiting. But perhaps the most significant change was the subtlest. It was a shift in our perception of time. We had always been a species obsessed with the immediate, the next quarter's earnings, the next election cycle. Now, people began to think in longer timescales. Urban planners started conversations about how cities might need to evolve for a species that knew it was part of a galactic community. We were not just processing the existence of another intelligence. We were, slowly, haltingly, and with a profound sense of dawning wonder, beginning to imagine ourselves as part of a family of minds, a community of civilizations scattered across the silent, starlit ocean of the galaxy. The bone-deep isolation that had defined human consciousness since we first looked up at the stars was, finally and tentatively, beginning to end. By January 2026, the question was no longer if humanity would reach out, but how. The passive act of listening and the single symbolic radio reply had been historic, but they were not enough. The visitors were not a distant, static signal. They were physical objects, right here, right now, moving through our solar system. To truly understand them, to look them in the eye, we had to go to them. The decision was made in the corridors of power and the labs of the world, space agencies. Humanity would send a spacecraft to rendezvous with 3I Atlas. The idea was audacious to the point of insanity. It was a plan born of necessity, a mission forged in the crucible of an impossible deadline. In the normal, sedate world of interplanetary exploration, mission planning is a process that unfolds over decades. The Voyager probes, humanity's greatest emissaries to the outer solar system, had taken 8 years from concept to launch. The James Webb Space Telescope, our magnificent new eye in the cosmos, had required 3 agonizing decades of design, construction, and testing. We did not have decades. We did not have years. We had months. 3I Atlas was a fleeting target. By the middle of 2026, it would have slingshotted around the sun and be accelerating back out into the interstellar dark, quickly moving beyond the reach of any spacecraft humanity could conceivably build. The launch window was not a comfortable bay. It was a knife's edge, a brief, unrepeatable opportunity measured in weeks. To meet it, the mission could not be designed. It had to be assembled, like a race car cobbled together in a garage overnight from the best parts available. The Herculean task of leading this impossible effort fell to Dr. Robert Braun, a legendary engineer formerly of NASA's Jet Propulsion Laboratory. Braun was a man known for his relentless pragmatism and his almost allergic aversion to bureaucratic inertia. He convened an emergency international mission design team, a dream team of the world's brightest engineers from NASA, ESA, JAXA, and, critically, the new generation of commercial space companies that had spent the last decade revolutionizing access to orbit. His philosophy, laid out in the first frantic planning session, was ruthlessly simple. Use only what works. Use only what we have. Accept risks we have never accepted before. Our only objective is the encounter. Everything else is noise. The mission architecture that emerged from this high-pressure incubator was a masterpiece of off-the-shelf ingenuity. The launch vehicle would be SpaceX's Super Heavy booster, the most powerful rocket ever built, originally designed to send humans to Mars. It was the only existing vehicle with the raw power to hurl a substantial payload onto the high-energy interplanetary trajectory required for the intercept. The spacecraft's main propulsion would be a solar electric system, a set of highly efficient ion engines proven on previous asteroid missions like Dawn and Psyche. These engines didn't provide a powerful kick, but a gentle, continuous thrust, perfect for the kind of precision navigation and delicate course corrections needed to catch a fast-moving, maneuvering target. The mission profile was as elegant as it was daring. A single, large mothership would launch in June 2026. It would perform a high-speed flyby of 3E Atlas in September. The entire encounter, the culmination of this frantic global effort, would last for roughly 6 hours. During that brief window, as it streaked past the enigmatic visitor, the mothership would deploy a swarm of smaller secondary probes, microsats, each designed to approach the object from a different angle, painting a complete, multifaceted picture of the target while the main spacecraft maintained a safe, respectful distance. The single greatest technical hurdle was guidance, navigation, and control, GNC. A traditional asteroid flyby is a celestial ballet choreographed years in advance. You know the target's orbit with exquisite precision. But 3I Atlas was not a passive rock. It had already demonstrated its ability to make small, deliberate course corrections. It was an active, unpredictable target. The mission spacecraft, therefore, could not rely solely on commands from Earth. The 8-minute light travel delay between the spacecraft and mission control would make real-time human intervention impossible during the final encounter. The spacecraft would have to think for itself. It would need a sophisticated autonomous navigation system, a powerful AI capable of tracking the target, predicting its movements, and adjusting its own trajectory in real time. It would have to be the smartest robotic explorer humanity had ever built. The scientific payload was selected with the same ruthless sense of priority. There would be no room for instruments designed for leisurely, decade-long studies. Every sensor had to answer the most urgent questions. A wideband radio receiver would act as a giant ear, monitoring the full spectrum of emissions from 3I Atlas, listening for any changes in its broadcast or any new, high-bandwidth communication attempts. A suite of high-resolution optical cameras, equipped with various spectral filters, would be the mission's eyes, documenting the object's physical structure and surface details with a clarity that ground-based telescopes could only dream of. A powerful laser communication system would be its voice, attempting to establish a high-bandwidth optical link, testing whether the visitor could respond to light as well as it did to radio. The most controversial element of the payload was a set of tiny contact probes. These were small, hardened microsats designed for an extremely close approach, potentially passing within mere meters of 3I Atlas's surface. They were equipped with a battery of sensors and, most audaciously, simple sampling systems, abrasive pads and sticky collectors that could, in theory, collect microscopic particles of material if the opportunity arose. Their primary purpose was observation from a dangerously close range, but the possibility of bringing back a physical sample, a piece of an alien machine, was a tantalizing, almost unbearable prospect. The James Webb Space Telescope, already a hero of the initial discovery phase, was given a critical new role. Its ability to track moving targets, while limited, could be used to provide final, high-precision trajectory updates for 3I Atlas just before the encounter. More importantly, its infrared sensitivity might detect thermal hot spots on the object's surface, revealing the location of internal power sources or propulsion systems. The ethical debate over the contact probes raged. COSPAR's planetary protection rules were clear about not contaminating other worlds. But what were the rules for touching a potential piece of property belonging to another intelligence? Was 3I Atlas a scientific specimen to be sampled, or was it an ambassadorial craft to be treated with diplomatic deference? The compromise was a cautious one. The contact probes would only be deployed if 3I Atlas appeared to be naturally shedding material, or if the visitor provided some form of unambiguous, apparent consent through its communication patterns. A direct, uninvited touch of the primary structure was strictly forbidden unless mission survival was at stake. To the astonishment of a world accustomed to political gridlock, international coordination proved remarkably seamless. The sheer scale and urgency of the mission made it a necessity. No single nation could do it alone in the time available. NASA contributed its unrivaled experience in mission operations and the use of the Deep Space Network. The European Space Agency provided its proven solar electric propulsion systems and navigation software. Commercial partners, freed from the usual government bureaucracy, supplied communications hardware and massive computational resources for trajectory modeling at unprecedented speed. The mission became a powerful, unintentional symbol of what humanity could achieve when faced with a challenge or an opportunity that transcended national borders. Contingency planning was a descent into a labyrinth of what-ifs. What if 3I Atlas detected the approaching spacecraft and changed course? What if it interpreted the mission as a threat and deployed defensive measures or a debris field? What if our own attempts to communicate triggered a hostile response? For every scenario, the team had to develop a predefined, autonomous response protocol. The spacecraft had to be ready for anything, from a peaceful exchange of information to a high-speed evasive maneuver. The encounter timeline was choreographed with the precision of a military operation. T-minus 6 hours, initial detection and approach. The main spacecraft would stabilize at a standoff distance of 10,000 kilometers, well outside any potential debris field. T-minus 4 hours, deployment of the microsat swarm. T-minus 2 hours, active communication attempts begin, pinging the visitor with both radio and laser signals. T-minus 0, closest approach of the primary spacecraft. For 6 hours, the spacecraft and its swarm would be humanity's robotic senses, our proxies in the first close encounter with an intelligence from another world. As the launch date in June 2026 approached, public attention became an intense, global fixation. Unlike previous interplanetary missions, which were followed mainly by scientists and space enthusiasts, the 3I Atlas rendezvous captured the collective imagination of the entire planet. The spacecraft was given a name, not by a committee, but by a global online poll of schoolchildren. The Seeker. It carried more than just scientific instruments. It carried digital archives of messages from world leaders, children's artwork from every nation, and symbolic artifacts representing the breadth of human civilization. The Seeker was more than a machine. It was a vessel for the hopes, fears, and boundless curiosity of an entire species. As it raced toward its appointment with an enigma, scientists and citizens alike prepared for discoveries that could rewrite every book and challenge every assumption we had ever made about our place among the stars. The rendezvous was just months away. The encounter itself was a silent 6-hour ballet performed in the void, a fleeting pas de deux between humanity's most advanced creation and a mystery from the stars. For 377 minutes, the Seeker and its swarm of probes streaked past 3I Atlas, their sensors drinking in a flood of data. Terabytes of images, spectral readings, radio emissions, and thermal scans that would take a generation of scientists to fully comprehend. But in the weeks and months that followed as that data cascaded back to Earth, the scientific community found itself walking a razor's edge, a treacherous path between a discovery that would redefine existence and a delusion born of our own desperate hope. The hardest part of extraordinary science is not the discovery itself. It is the agonizing, soul-searching process of proving to yourself that what you found is real. It is the battle against the most formidable and subtle of enemies, the human mind, its own desire to find meaning, to see a pattern in the static, a face in the clouds. This is the demon of pareidolia, and it haunted every single frame of data from the encounter. Dr. Elena Martinez, the chief scientist for the rendezvous mission, understood this better than anyone. She sat in the sterile, quiet control room at JPL, staring at a high-resolution image of 3I Atlas on the main screen. The object was breathtaking. It was a dark, impossibly thin sliver against the star-dusted black, its surface etched with a complex geometric pattern that looked for all the world like the intricate circuitry of a microchip, or the veins of a metallic leaf. The pattern seemed organized, repetitive, and utterly unnatural. They screamed, "Design!" But Martinez's mind, trained by decades of rigorous skepticism, immediately threw up a wall of caution. "The canals of Mars," she whispered to herself, a mantra of scientific humility. In the late 19th century, astronomers peering through primitive telescopes had seen what they were certain were long, straight, artificial canals on the Martian surface, irrefutable proof of an advanced civilization. They were, of course, optical illusions, a trick of light and shadow combined with the brain's insatiable hunger for patterns. Martinez was terrified that they were about to make the same mistake on a cosmic scale. The principle of "extraordinary claims require extraordinary evidence" was no longer just a catchy phrase. It was the sacred, guiding law of the entire project. To enforce it, the international science team implemented a set of verification protocols so stringent they bordered on institutional paranoia. They knew the world was watching, and a single premature announcement that later proved wrong would not just be embarrassing. It would shatter the credibility of science for a century. First, they implemented a system of pre-registered analyses. Before any team was allowed to look at a new piece of data, they had to publicly file a detailed plan outlining exactly what hypothesis they were testing and what statistical methods they would use. This prevented the scientific equivalent of goalpost moving, the unconscious temptation to tweak your analysis after the fact to make the results look more significant. Second, they used blind injections. Unbeknownst to the primary analysis teams, a separate group of engineers would occasionally insert fake, artificially generated signals into the raw data streams. A fake radio burst, a doctored image with a synthetic geometric pattern. The purpose was to test the system. If a team reported a discovery that turned out to be a blind injection, it was a sign that their detection algorithms were too sensitive, too prone to finding false positives. It was a humbling but essential check on their own fallibility. The most powerful tool, however, was the establishment of independent adversarial analysis pipelines. The full data set from the encounter was given to 5 different, geographically separated teams in Pasadena, Darmstadt, Tokyo, Mumbai, and Santiago. Each team was given the same raw data but was forbidden from communicating with the others. They had to develop their own software and their own methodologies from scratch. Only when all 5 teams, working in complete isolation, reached the same conclusion about a specific finding, would it be considered even provisionally verified. If they disagreed, it meant the signal was ambiguous, and it was thrown back for more work. The central debate revolved around the 3 competing models for 3I Atlas, each now armed with new predictions to be tested against the encounter data. The engineered light sail. Hypothesis. This model proposed that 3I Atlas was a fully artificial autonomous probe. It explained the extreme geometry, the controlled rotation, the thermal management, and the radio broadcasts. Its primary prediction was that the close-up data would reveal definitive technosignatures, materials, structures, or energy emissions that were impossible to form through natural processes. The team in Pasadena, analyzing the spectroscopic data from the contact probes, found what they thought was a smoking gun, trace amounts of an isotope of boron that, according to our understanding of stellar nucleosynthesis, should not exist in nature. The exotic natural fragment. Hypothesis. This model argued that 3I Atlas was a new and unknown category of natural object, perhaps a nitrogen iceberg chunk blown off a Pluto-like exoplanet, or a fragment from a stellar collision containing bizarre, super-dense metallic alloys. It could potentially explain the object's strangeness without invoking alien intelligence. Its main prediction was that while the materials might be exotic, their underlying formation could eventually be explained by known, if rare, astrophysical processes. The team in Darmstadt, focusing on the same boron isotope, developed a complex but plausible model showing how it could be formed in the heart of a rare type of carbon star during its death throes. The smoking gun was suddenly shrouded in smoke, the normal comet hypothesis. This was the most conservative model, insisting that 3I Atlas was fundamentally just a comet like 2I Borisov, and that its apparent anomalies were a result of its unique orientation and our own misunderstanding of cometary physics at close range. It predicted that the data, once fully analyzed, would reveal conventional cometary behavior, like jets of gas erupting from fissures in a nucleus. And indeed, the team in Tokyo, analyzing the high-resolution images, found plume-like structures that looked remarkably similar to the gas jets seen on comets in our own solar system. Every piece of evidence seemed to point in three directions at once. The radio emissions, with their embedded prime numbers, were almost irrefutable evidence of intelligence. Natural processes simply do not create mathematically modulated, narrowband signals. But the ambiguous spectroscopic data and the comet-like plumes kept the door open for a natural explanation, however unlikely. The historical context of Oumuamua loomed large over the entire process. That first interstellar visitor had also shown anomalies that had led some, most notably Harvard's Dr. Avi Loeb, to speculate about alien technology. But a later, more thorough analysis had demonstrated that conventional, if unusual, outgassing from a hydrogen iceberg or a nitrogen-rich body could explain all the observed data without resorting to aliens. The lesson was soberingly clear. Nature's capacity for the strange and unexpected is often greater than our own imagination. The extraordinary hypothesis should always be the very last resort. The most tantalizing and maddeningly ambiguous results came from the laser communication experiment. During the encounter, the seeker had transmitted a series of structured light pulses at 3I Atlas, a simple sequence based, once again, on prime numbers. In response, the surface reflectivity of the object, measured by the microsat probes, had appeared to change in a pattern that perfectly mirrored the incoming laser pulses. It was as if the object's skin was blushing in time with the message. But the space environment is a chaotic place, filled with charged particles and complex plasma interactions. The team in Mumbai, tasked with analyzing this specific experiment, could not definitively rule out the possibility that the reflectivity changes were simply an unusual plasma effect triggered by the laser AS energy rather than an intentional reply. For 6 months, the 5 teams worked in secret, the weight of their task a crushing burden. Finally, in the early spring of 2027, they came together for the first time to compare their results. The mood in the video conference was tense, a mixture of exhaustion and profound anticipation. One by one, they presented their findings. On many of the key points, they had reached a consensus. But on the ultimate question, they remained divided. The evidence for artificiality was powerful, suggestive, and tantalizingly close to conclusive. But it was not yet absolute. Several key observations, particularly the radio signal, remained completely unexplained by any natural process. Yet, the possibility of some new, unknown astrophysical phenomenon, an unknown unknown, could not be definitively ruled out. The interim report they released to the world was a masterpiece of carefully calibrated scientific language. It stated that 3I Atlas exhibits a suite of coordinated properties that are difficult to explain through currently understood natural processes. While the possibility of an artificial origin is consistent with several lines of evidence, more analysis is needed to reach a definitive conclusion. This cautious, non-committal phrasing was, in itself, a bombshell. For the first time in human history, the global scientific community, with all its rigor and conservatism, was officially acknowledging that it was seriously considering the possibility that we had encountered a piece of technology from another civilization. The burden of proof was still immense, but with every new analysis, with every independent confirmation of an anomaly, with every failed attempt by the skeptics to find a natural explanation that fit all the facts, the balance was slowly, inexorably shifting. The razor's edge between proof and pareidolia remained terrifyingly sharp, but humanity was beginning to lean, with a tremor of awe and fear, toward a conclusion that would change everything. While the physicists and astronomers argued over the physical nature of Three-Eye Atlas, a different kind of detective story was unfolding in the quiet, climate-controlled server rooms of the world's signal processing centers. The visitors had not just sent a messenger, they had sent a message. And that message, encoded in the rhythmic pulse and subtle frequency shifts of their radio transmissions, was not a poem or a philosophical treatise. It was something far more complex, practical, and, in its own way, far more profound. It was an instruction manual. The Herculean task of decrypting this cosmic signal fell to an international team led by Dr. Yuki Tanaka at the Tokyo Institute of Technology. Dr. Tanaka was not an astronomer. She was a master of information theory, a cryptographer whose mind saw the universe not as a collection of stars and planets, but as a vast, noisy channel of information, filled with signals waiting to be decoded. Her team was a global consortium of linguists, mathematicians, computer scientists, and signal analysts, the intellectual heirs of the Bletchley Park codebreakers who had deciphered the Enigma code in World War II. Their task, however, was infinitely more challenging. They were trying to read a book written in a language they had never seen, using a grammar that might not follow any human logic. The initial breakthrough had been the prime numbers. That simple universal sequence was the key, the crib, that allowed them to unlock the first layer of the message. They quickly realized that the prime number sequences were not the message itself, but rather the headers, the digital equivalent of a chapter title. Each unique prime sequence served as an introduction to a new, more complex block of data that followed. It was a brilliantly designed system, a layered, self-interpreting text that taught you how to read it as you went along. Layer 1. The Mathematical Foundation. The first and simplest data blocks were a patient, methodical lesson in the sender's mathematical language. The prime numbers gave way to simple algebraic relationships, A plus B C. Then came geometric principles, starting with the value of pi, encoded to thousands of decimal places, and moving on to the Pythagorean theorem and the basic axioms of Euclidean geometry. The visitor was not assuming any shared knowledge. It was building a common language from the ground up, brick by mathematical brick. It was a display of staggering intellectual patience, a teacher establishing a shared vocabulary with a new student before attempting to convey more complex ideas. Layer 2. The Physical Constants. Once the mathematical language was established, the message transitioned to physics. The visitor began transmitting the fundamental constants of the universe, the fine structure constant, Planck's constant, the speed of light, the gravitational constant. But there was a stunning detail. The values they transmitted were expressed with a level of precision that far exceeded humanity's own best measurements. It was a subtle but undeniable flex of their scientific prowess. They weren't just confirming that we lived in the same universe. They were gently demonstrating that they understood its fundamental operating system with a far greater clarity than we did. Layer 3. The Technical Specifications. This was the layer where the message transformed from a scientific exchange into something far more tangible and world-altering. The visitor began transmitting what could only be described as a set of highly detailed technical blueprints. They were the instructions for constructing a device. The device was a powerful, long-range, steerable radio beacon, an interstellar communication node with capabilities orders of magnitude beyond any transmitter humanity had ever conceived. The design was a masterpiece of thoughtful engineering. It did not assume unlimited resources or magical, unobtainable materials. Instead, the specifications were elegantly tailored to the capabilities of a 21st-century civilization. The beacon would require a vast, distributed array of precisely coordinated transmitters, but the individual components, the antennas, the amplifiers, the power sources, were all based on physics and materials that human engineers could, with a concerted effort, develop and manufacture. More remarkably, the design was specifically customized for our world. It included subtle optimizations that accounted for Earth's precise rotation period, the strength of our planet's magnetic field, and the specific absorption characteristics of our ionosphere. This wasn't a generic, one-size-fits-all template. It was a bespoke design, suggesting that the visitors had not just detected our radio signals, but had spent considerable time studying the detailed properties of our planet before making contact. Layer 4. The Network Map. This was the most profound and humbling layer of all. After providing the complete schematics for the beacon, the message began to describe how to use it. It transmitted what Dr. Sarah Kim at MIT, a member of the decryption team, began to call the network map. It was a description of how the proposed beacon was designed to interface with a pre-existing, galaxy-wide communication system. The map showed the locations of what appeared to be other active nodes or relay stations, positioned at strategic locations throughout our local sector of the galaxy. The locations were described by precise astronomical coordinates. Some of these coordinates corresponded to known, stable, sun-like stars. Others, more bizarrely, pointed to seemingly empty regions of deep space. When astronomers cross-referenced these empty coordinates, they realized they corresponded to gravitational lenses, points where the gravity of a massive foreground object like a star cluster or a black hole would naturally focus and amplify radio signals traveling from behind it. The visitor was describing a communications network of staggering sophistication, a galactic internet that used the very structure of space-time as its physical infrastructure. Throughout all these technical layers, there was another subtle stream of information woven into the data, what the team began to call the ethical payload. The message contained abstract symbols and logical relationships that clearly referred to biological systems and planetary environments. There were implicit warnings about the dangers of electromagnetic radiation, with diagrams that seemed to suggest powerful transmitters should always be positioned in space, away from the fragile biospheres of inhabited worlds. There were concepts that could only be interpreted as principles of conservation and sustainability. It was as if the manual for joining the Galactic Club came with a clear set of community guidelines. Be mindful, be quiet, and respect life. The encoding of the message itself was a work of art. Dr. Tanaka and her team marveled at its genius. Every data packet was wrapped in multiple layers of error-correcting codes, ensuring the message could be perfectly reconstructed even if large portions of the transmission were lost or corrupted by solar noise. A clever system of temporal scaffolding allowed the entire message to be reassembled in the correct order, despite the complexities of intermittent signals from a moving transmitter. The message even included explicit markers that defined its own dimensional units, coordinate systems, and byte order, elegantly sidestepping all the potential ambiguities that could plague a first contact between species with different mathematical traditions. It was a message designed to be universally, unambiguously decodable by any intelligence capable of receiving it. But perhaps the most intriguing aspect of the message was what it did not contain. There was no art, no music, no poetry. There were no personal greetings, no cultural artifacts, no philosophical exchanges or religious proclamations. There was no "we come in peace." The visitor's message was purely, ruthlessly functional. It was a technical manual, a gift of knowledge, an invitation. The staggering implication began to sink in. Humanity was not just receiving its first message from an alien civilization. We were being invited to join a conversation that was already in progress. We were being handed the keys to the kingdom, a blueprint for building our own node on a communication network that had likely been operating across the galaxy for eons. The global citizen science community had played an invaluable role in the decryption. The sheer complexity of the signal meant that certain pattern recognition tasks were too vast for even the most powerful supercomputers. These tasks were farmed out to the public via platforms like Zooniverse, allowing hundreds of thousands of volunteers to contribute their own cognitive power. Schoolchildren in classrooms from Ohio to Osaka helped identify repetitive patterns that professional automated systems had missed. This collaborative global effort represented the largest coordinated intellectual project in human history. As different teams, working independently, began to reach the same interpretations of key portions of the message, a convergent translation emerged, giving the team high confidence that they were on the right track. The message was real, and its meaning was becoming terrifyingly clear. There was one final, chilling component to the message: a deadline. Woven into the technical specifications for the beacon were a series of temporal coordinates, precise timing requirements for when the beacon would need to be initialized and synchronized with the broader network to be accepted. It wasn't an ultimatum, but a simple statement of operational reality. If humanity wanted to join the galactic community, we had a limited window of opportunity in which to build our entry ticket and present it at the gate. The decision point was approaching with the speed of a comet. The visitor had given us the knowledge. The technology, while challenging, was achievable. The choice was no longer a philosophical abstraction. It was an engineering problem with a deadline. Do we build the beacon? Do we knock on the door and announce our presence to whatever civilizations might be listening across the galaxy? Building it would be an irreversible act. Once activated, Earth's participation in the galactic network would be a permanent fact, visible to any intelligence monitoring the channels. We would no longer be a lonely world shouting into the darkness. We would become part of something vast, ancient, and utterly beyond our current understanding. The choice was simple, and it was the most important decision our species would ever make: remain alone or join the conversation that had been waiting for us among the stars since before the first human ever looked up in wonder. The moment the global consensus shifted from "should we" to "how do we," the world was plunged into a new kind of industrial revolution. This was not a revolution of steam or silicon, but of starlight and space-time. The decision to build the beacon, to take the visitors up on their staggering offer, became a global project of such immense scale and complexity that it would act as a forge, burning away old political animosities, reshaping economic realities, and hammering human society into something new and unrecognizable. The engineering challenges alone were monumental. The visitors' blueprints were a roadmap to a technology centuries ahead of our own, but they were not a magical recipe. They were a set of physical principles, a cosmic engineering textbook that we had to learn to read and then translate into practical reality. The first and most critical technology was the development of the transmission elements themselves. The beacon was not a single, massive dish, but a distributed array of thousands of individual transmitters. The blueprints called for ultra-thin metamaterials, substances engineered at the nanoscale to manipulate electromagnetic waves with a precision that was, to our engineers, like watching a wizard perform magic. Research labs at MIT, Caltech, and the Max Planck Institute went into overdrive, repurposing nanotechnology developed for medicine and computing to begin rapid prototyping. They were no longer just building better circuits. They were learning to weave the very fabric of electromagnetism. The second challenge was timing. For the distributed array to function as a single, coherent transmitter, every single one of its thousands of elements, potentially scattered across hundreds of thousands of kilometers of space, had to operate in perfect, unyielding synchronization. The timing precision required was on the order of nanoseconds, a stability that had to be maintained not for minutes or hours, but for years. This demand kick-started a renaissance in quantum timekeeping. New, more robust atomic clocks, based on the quantum entanglement of atoms, became the top priority, pushing the boundaries of both physics and engineering. The final piece of the technical puzzle was power. The beacon, during its peak transmission phases, would require gigawatts of electrical power, the output of several large nuclear power plants. This immediately sparked a fierce global debate. Building the beacon with fossil fuels would be a cosmic irony of the highest order, reaching for the stars by further poisoning our own cradle. The environmental movement, once sometimes at odds with the perceived extravagances of the space program, now found itself in a powerful alliance with the beacon's advocates. The project became a powerful catalyst for a global transition to sustainable energy. Massive solar farms blossomed in the world's deserts, and, after decades of slow progress, international investment poured into nuclear fusion research, a technology that suddenly seemed not just a distant dream, but a practical necessity. But for every technological breakthrough, a shadow of dual-use implication emerged. The same exquisitely precise quantum timing systems needed for interstellar communication could also be used to guide intercontinental ballistic missiles with an accuracy that would render all existing defenses obsolete. The high-power transmitter arrays, if focused, could theoretically be used to interfere with or even disable the satellites of a rival nation, effectively serving as a new form of directed energy weapon. This terrifying potential forced an unprecedented level of international transparency. Planetary defense advocates, once focused on asteroids, now turned their attention to the beacon. They argued successfully that the technology was simply too powerful to be developed in secret. A new treaty, an addendum to the Outer Space Treaty of 1967, was drafted and ratified with astonishing speed. It mandated that any nation or organization developing interstellar communication technologies must submit to a rigorous regime of international inspections and verification procedures. For the first time, the world's great powers agreed to open the doors of their most advanced laboratories to their rivals, a level of trust born not of idealism, but of shared existential fear. Legal frameworks designed for a world of purely terrestrial concerns struggled to catch up. The old Outer Space Treaty governed activities in space, but said nothing about communicating from space with alien civilizations. The Liability Convention of 1972 could assign blame if a satellite fell on someone's house, but it had no framework for dispute over interstellar messaging rights. A new field of law, contact governance, was born. Legal scholars from around the world began drafting model treaties, borrowing concepts from arms control, environmental law, and even maritime law to create a framework for humanity's new role as an interstellar actor. The philosophical question of who speaks for Earth became a brutally practical political problem. With the visitors' blueprints in hand, the race was on. NASA, leveraging its decades of experience, proposed a massive international consortium, modeled on the successful International Space Station partnership. China, seeing a historic opportunity to leapfrog the old space powers, announced ambitious plans for its own independent beacon system. Private companies, led by visionary and often mercurial tech billionaires, submitted their own proposals, arguing that the ruthless efficiency of commercial competition, not the slow pace of government bureaucracy, was the only way to meet the visitor's deadline. This raised the critical issue of data rights. Would the beacon's transmissions and any potential replies be treated as public information, the shared heritage of all humanity? Or would the nations and organizations that paid to build the system have the right to control access to this galactic fire hose of information? The precedent set by Earth's first beacon would likely shape the governance of interstellar relations for generations to come. The economic implications of this new reality were tidal. The price of the rare Earth elements required for the metamaterials and quantum clocks triggered a new commodity supercycle, a space race that was fought not in orbit, but in the mines of Africa and South America. But the most profound economic shift was psychological. For the first time, major corporations and investment funds began to think on truly long-term horizons. What were the market opportunities in a society that was part of a galactic network? What new industries might emerge? Investment began to flow into projects that might not see a return for 50 or 100 years. The cosmic perspective was fundamentally altering the human conception of time and value. The beacon's physical location became another point of intense debate. Building the massive power plants and transmitter arrays on Earth raised significant environmental concerns. The far side of the Moon, naturally shielded from Earth's own chaotic radio noise, was the ideal location for the sensitive receiving equipment. Nearby asteroids could provide the raw materials for construction in space, avoiding the immense environmental cost of launching millions of tons of material out of Earth's deep gravity well. The cislunar region, the area of space between the Earth and the Moon, suddenly became the most valuable real estate in human history, a new frontier for industrial development. International cooperation emerged not from a sense of high-minded idealism, but from sheer practical necessity. No single nation possessed all the resources, all the technology, and all the manufacturing capacity to build the beacon on the compressed timeline. The American genius for systems integration, the European expertise in precision engineering, the Chinese prowess in large-scale manufacturing, and the Indian leadership in software development all had to be brought together. The Beacon project became the ultimate catalyst for the kind of global collaboration that had remained frustratingly elusive for purely terrestrial challenges like climate change and poverty. But this new cooperation was fragile, fraught with the risks of old rivalries. The shared beacon system would need a governance structure that could survive political turmoil, economic recessions, and even international conflicts. What would happen if the participating nations disagreed on the content of a message? How would humanity resolve a dispute when the consequences might affect our standing in a galactic community we did not yet understand? As the first construction ships began their journeys toward the Moon and the designated asteroid mining sites, it was clear that humanity was transforming itself. We were no longer just building a machine. We were building a new identity. The Beacon project was a galactic forge, and in its fire the petty squabbles and divisions of our terrestrial childhood were beginning to burn away, leaving behind the harder, stronger, and more unified alloy of a species preparing to take its first tentative step onto the galactic stage. We were no longer just a collection of nations on a single, isolated planet. We were preparing to become citizens of a galaxy. By the winter of 2027, the last of the visitors had departed. 3I Atlas and its enigmatic companions had swept through our solar system like a phantom fleet, their signals fading as they accelerated back along their hyperbolic trajectories toward the cold, silent dark of interstellar space. They were gone, but they had left behind an echo, a resonance that continued to shake human civilization to its very core. They had left us with their message, their instruction manual, and, most importantly, a choice. The frenetic energy of the initial mission planning and the technological sprint had given way to a more sober and deeply philosophical global debate. The blueprints were on the table. The capability was within our grasp. But now, standing at the crossroads, humanity had to decide which path to take. The choice was deceptively simple: build the beacon and join the conversation, or remain silent and listen. But the implications of that choice were monumental, reaching into the very definition of what it meant to be human and what our future as a species would be. 3 distinct philosophies emerged, each with passionate advocates, each representing a different facet of the human psyche: our ambition, our caution, and our pragmatism. These 3 scenarios dominated the discussions in the chambers of the United Nations, in the halls of academia, and in the digital town squares of a globally connected populace. Scenario 1: the silent watchers. This was the conservative path, the path of caution and patience. Its proponents argued that we had been given a gift of unimaginable value, the certain knowledge that we are not alone. That, for now, should be enough. We should immediately and massively expand our passive SETI capabilities, building the sensitive receiving arrays on the far side of the Moon as the visitors' plan suggested, but keeping the transmitters powered down. We would become a species of listeners, eavesdropping on the galactic network, learning about its members, its rules, and its history before we ever announced our own presence. The logic was compelling. We were the cosmic equivalent of an uncontacted tribe that had just discovered a global satellite phone network. To immediately pick up the phone and start making calls without understanding who was on the other end would be reckless, arrogant, and potentially suicidal. Better to spend a few decades or even a few centuries in quiet observation. We could learn the political landscape, identify potential allies and threats, and allow our own technology and social structures to mature. We could meet our potential neighbors as equals, or at least as knowledgeable participants, rather than as naive, babbling children who had just stumbled into a conversation between adults. The silent watcher path was safe, reversible, and it allowed humanity to develop on its own timeline. But the critics, and there were many, pointed to the immense cost of this isolation. The beacon specifications provided by 3i Atlas were a technological gift, a shortcut that could advance human science by centuries. To refuse that gift, to choose to remain in a state of self-imposed technological infancy while a galaxy full of knowledge hummed just beyond our reach, seemed to many like an act of timid self-sabotage. It was the path of fear, they argued, not wisdom. Scenario 2. The cautious knock. This was the middle course, a pragmatic compromise between silence and shouting. It proposed building the full beacon system as designed, but activating it in a carefully controlled, incremental way. This path would establish our capability to join the network without immediately committing to full, active participation. The beacon would be brought online at a minimal power level, transmitting a simple, repeating signal, perhaps just the prime numbers again, on a limited, intermittent schedule. It would be the cosmic equivalent of a quiet, polite knock on the door, rather than kicking it down. It would announce our presence and our technological maturity, a signal that we had received and understood the invitation. But it would not be a full-throated cry for attention. The governance structures for this path would be paramount. An expanded UN framework, a new Interstellar Contact Council, would be formed. No single nation or corporation would control humanity's voice. Every message, every transmission schedule, would require a supermajority vote from this international body. It would be slow, bureaucratic, and frustrating, but it would ensure that our first words on the galactic stage were spoken with the collective wisdom of the entire species. The cautious knock was a path of measured engagement, balancing the potential rewards of contact with the profound risks of the unknown. Scenario 3. The bold leap. This was the ambitious path, the one that resonated with the deepest, most exploratory instincts of the human spirit. Its proponents argued that the visitor's message was not just an invitation, it was an opportunity with an expiration date. The temporal coordinates embedded in their transmission were a clear indication that the galactic network was a dynamic system. To join it effectively, we needed to do so while their welcome packet was still relevant. Hesitation was, in itself, a decision to fall behind. This approach called for a full, committed effort to build and activate the beacon within a single decade. It promised a future of rapid technological advancement, of immediate access to the unimaginable wealth of knowledge that a millennia-old galactic network might contain. The solutions to our most pressing problems, climate change, disease, resource depletion, might be waiting for us just a single message away. Early participation could provide humanity with the scientific and technological advantages needed to not only survive, but to thrive and expand beyond our own solar system. But the risks were equally immense. A full, active presence on the network would make Earth a permanent, visible, and unignorable fixture in the galactic community. We would be committed to relationships and obligations we could not possibly understand. We would be exposing our young, fragile, and often fractious civilization to intelligences whose motives and capabilities were a complete unknown. Once we stepped through that door, there might be no going back. Withdrawal might be seen as an insult, or worse, an impossibility. The bold leap was the ultimate gamble, a bet on the fundamental benevolence of the universe, and on our own ability to adapt and survive in a cosmos that was suddenly far more crowded than we had ever imagined. The global debate transcended all traditional political and social boundaries. Progressive environmentalists, normally advocates for bold action, found themselves arguing for the cautious observational approach of the silent watchers, aligned with conservative military strategists who feared the unknown security risks. Libertarian tech billionaires, usually opposed to government oversight, championed the UN-governed, measured engagement of the cautious knock, allied with international diplomats. The cosmic perspective had a way of scrambling all of our old terrestrial allegiances. Public opinion, measured in a constant stream of global polls, remained engaged but deeply divided. There was majority support for building the beacon, but the specifics of its activation were a source of intense debate. The most popular approach seemed to be a hybrid, a fusion of all three scenarios. Build the necessary infrastructure with the urgency of the bold leap, but activate it with the extreme caution of the cautious knock while simultaneously funding a massive, passive listening program as advocated by the silent watchers. While humanity debated its future, the work of scientific preparation accelerated. The Galileo Project, a real-world scientific initiative originally conceived to search for signs of extraterrestrial technology, evolved into a permanent, well-funded international program. Its expanded mission was to monitor for any new interstellar visitors, to continue the deep analysis of the 3I Atlas data, and to develop the scientific foundations for future contact scenarios. Prototype beacon components, built by the new international consortiums, were already undergoing testing in Earth orbit and at the stable Lagrange points between the Earth and the Moon. The technical challenges were formidable, but they were yielding to the relentless pressure of human ingenuity. But the engineering timeline remained the great moderator of even the most ambitious plans. Full beacon capability would require at least a decade of focused, global effort, and probably longer. As the decade drew to a close, humanity's choice began to crystallize around a single, fundamental question of identity. Were we explorers, defined by our relentless urge to push into the unknown, to see what lies over the next horizon? Or were we preservers, defined by our commitment to protecting the fragile, beautiful home we had already achieved? The final decision, when it came, reflected both of these deep-seated and often contradictory human impulses. Humanity would build the beacon. We would take our place in the galactic community. But we would do so on our own terms, with a caution that bordered on paranoia, preserving our autonomy and protecting our homeworld at all costs. The compromise satisfied neither the most daring nor the most fearful, but it represented a fragile, hard-won consensus. It was the choice of a species deciding, collectively, who it wanted to become. The night sky looked different now. The glittering points of light that had once been symbols of our loneliness were now potential destinations, the homes of intelligences whose messages might already be crossing the void toward us. The cosmos had transformed from a vast, empty cathedral into a sprawling, noisy, and incomprehensibly vast neighborhood. In the end, perhaps this was the greatest gift of 3I Atlas. It was not the technology, not the blueprints, not the invitation. It was the simple, profound, and world-shattering knowledge that we had never, ever been alone. The children who came of age in the 2030s and 2040s were different. They were the first generation of human beings to grow up in a world that knew, with absolute certainty, that it was not alone. For them, the existence of extraterrestrial intelligence was not a shocking revelation or terrifying upheaval. It was simply a foundational fact of their reality, as mundane and as profound as the sky being blue or the grass being green. They were the starlight generation, and their perspective on life, the universe, and humanity as place in it was as different from their parents as their parents had been from those who lived before the Internet. This generational divide was perhaps the most subtle but most significant long-term consequence of the contact. Older adults, those who had grown up under the cold, silent stars of the old paradigm, often struggled to fully integrate the new reality. For many, the knowledge of the galactic community remained an intellectual abstraction, a fascinating but unsettling piece of news that never quite penetrated the core of their being. They still spoke of aliens, with a faint, almost unconscious undertone of us versus them. They worried about the risks, the unknowns, the potential for conflict. Their worldview, forged in a crucible of terrestrial competition and existential loneliness, found it difficult to expand to a truly cosmic scale. But for their children, there was no before. They learned about the Arecibo message and the arrival of 3I Atlas in their history classes, alongside the voyages of Columbus and the Apollo moon landings. The prime number sequence broadcast by the visitor was as familiar to them as their own multiplication tables. The faint, ongoing signals from the now active listening posts on the moon were the background hum of their childhood, a constant, gentle reminder of the vast conversation taking place just beyond their world. The educational curricula of their time reflected this profound shift. Mathematics and physics were no longer taught as abstract theoretical subjects. They were presented as what they had now truly become, the practical tools of interstellar communication. A child learning about the electromagnetic spectrum in a middle school science class was also learning the very language they might one day use to speak with a being from another world. The prime numbers were not just a mathematical curiosity. They were the first word in the first sentence of humanity's first cosmic conversation. This gave these subjects an immediacy and a sense of purpose that had been absent for previous generations. The question was no longer, "Why do I need to learn this?" but "What will I be able to say with this?" The psychological impact was immense. The Starlight generation seemed to be born with a kind of innate cosmic perspective that their elders had to struggle to achieve. They exhibited lower levels of tribalism and nationalism in psychological studies. When you are raised with the knowledge of a galaxy full of diverse intelligences, the minor genetic and cultural differences between human beings on a single planet tend to seem less significant. The concept of humanity as a single, unified entity was not an idealistic dream for them. It was a practical necessity for participating in galactic affairs. They were also a generation of profound and sometimes melancholic dreamers. They consumed a new kind of science fiction, one that was less about space battles and alien invasions and more about the deep, philosophical challenges of interspecies communication and ethics. They wrestled with questions their grandparents had never even thought to ask. What are our moral obligations to a species we have never met? Is intelligence always accompanied by consciousness? Is life in any form inherently sacred? This new perspective manifested in their career choices. The brightest young minds of the generation flocked not to Wall Street or Silicon Valley, but to fields that were now at the heart of the human enterprise: astrobiology, xenolinguistics, information theory, and long-term ecological planning. They were not just seeking careers, they were seeking roles in the grand, multi-generational project of preparing humanity for its entry into the galactic community. The development of the beacon, a project that would span their entire childhood and young adulthood, became the defining narrative of their time. The massive construction projects in cislunar space, the orbital assembly of the transmitter arrays, the mining of asteroids for raw materials, the establishment of the permanent research base on the lunar far side, were their generation's equivalent of the great cathedral constructions of the Middle Ages. They were acts of collective faith and engineering, projects built not for the immediate gratification of their creators, but for the benefit of generations yet to come. Support groups and counseling services, which had initially emerged to help adults cope with contact syndrome, evolved into something different for the young. They became contact integration workshops, spaces where young people could discuss the unique psychological pressures and opportunities of their reality. They talked about the anxiety of living in a world whose future was so vast and unwritten, but also about the incredible sense of purpose that came with it. Children, as they always do, adapted most quickly and completely. They seemed almost unsurprised by the whole affair, as if the adults had simply taken a very long time to catch up with a truth they had always intuitively understood. The universe was big, it was full of wonders, And of course there were other people out there. To them, it was obvious. Their artwork was filled with images of strange new worlds and friendly, bizarrely shaped creatures. Their games were about exploration and communication, not conflict. They seemed to possess a natural, unjaded optimism about the future of interspecies relations. But this was not a generation without its own unique burdens. They carried the weight of expectation. They were the ones who would inherit the beacon. They would be the first to truly speak for Earth. Their parents and grandparents were building the telephone, but they would be the ones to make the first real call. This created a palpable sense of pressure, a feeling that their every action, their every decision, was being judged not just by their fellow humans, but by the silent, listening audience of the stars. They also lived with a new kind of existential dread. The old fears of nuclear war or climate collapse, while still present, were now dwarfed by a larger, more abstract terror. The fear of getting it wrong. The fear of saying the wrong thing, of committing some unintentional galactic faux pas that could have devastating consequences, of failing to live up to the immense promise of this moment. They were the children of a species that had just been handed a loaded gun in a dark room, and they were the ones who would have to learn how to handle it responsibly. As the decade of construction progressed and the beacon neared its initial activation, the generational divide became a tangible force in global politics. The leaders of the old world, the ones who still thought in terms of nation-states and quarterly profits, were slowly being replaced by a new generation of leaders who had grown up with the starlight perspective. These new leaders spoke a different language, one of global cooperation, long-term thinking, and a profound sense of humanity's shared destiny. They were not less patriotic, but their patriotism was now nested within a larger, planetary identity. The Starlight generation was humanity's first attempt to create a new kind of human being, one forged in the knowledge of a wider universe. They were more connected, more thoughtful, and more burdened than any generation that had come before. They were the ones who would have to navigate the treacherous, exhilarating, and unknown waters of the galactic community. The future was no longer just about the fate of nations, or even the fate of the planet. It was about the fate of a species taking its first, trembling steps out of its cradle and into the vast, starlit neighborhood that had been waiting for it all along. By the mid-2030s, a new kind of normal had settled over the planet. The initial, vertiginous shock of the contact had been absorbed into the fabric of daily life. The construction of the beacon, the great work, as it was now called, was a constant humming background to human existence. Its progress was reported on the nightly news alongside stock market updates and weather forecasts. Giant, gossamer-thin transmitter panels, assembled in Earth orbit, would catch the sunlight and glint like new, man-made stars in the night sky. The project was a testament to humanity's shared purpose, but it was also slow, methodical, and, for a generation hungry for the next chapter, achingly routine. The Starlight generation was in college, studying for a future that still felt a long way off. The world, it seemed, had settled in for a long, patient wait. The wait ended on the day humanity's new ear was opened to the cosmos. On the far side of the moon, nestled in the permanent radio-silent shadow of the giant Hertzsprung crater, the Kepler Farside Array, KFA, came online. It was the most sensitive listening device ever created, a sprawling, spiderweb-like network of superconducting antennas, shielded from the ceaseless radio chatter of its home planet by 3,500 kilometers of solid rock. The KFA was the direct result of the visitor's message, the listening post the blueprints had advised building first. It was designed not to talk, but to listen with a clarity and sensitivity that was almost absolute. Its first historic task was not to search for new, unknown signals, but to perform a simple act of verification, to point its incredible ear at the coordinates provided in the visitor's network map and confirm that the galactic internet was real. The first target was chosen for its clarity and promise. It was not a star, but one of the empty coordinates from the map, a point in space designated L115, located in the direction of the Lyra constellation. According to the visitor's data, this point was a natural gravitational lens, where the mass of an intervening star cluster would bend space-time and magnify any signal passing through it from a more distant source. The team at the KFA Operations Center, a state-of-the-art facility in geosynchronous orbit, keyed in the coordinates. The entire array, kilometers of delicate machinery, silently pivoted, its focus aimed at a patch of sky that was, to the human eye, completely black and unremarkable. For the first few hours, there was only the faint background hiss of the universe. And then, slowly, painstakingly, as the computers integrated the faint signal over time, a pattern began to emerge from the static. It was there. A faint, structured, narrowband signal broadcast on one of the frequencies indicated in the network map. A wave of jubilation and relief washed through the control room. It was real. The visitors had been telling the truth. The network map was not a trick or a test. It was a genuine guide to a living, breathing, galactic community. The news was released to the public, and for a moment, the world celebrated. We had confirmed it. The lights were on in the cosmic neighborhood. The signal from L115 was weak, but it was coherent. The task of analyzing its content fell to the new generation of cryptographers at the Institute, now led by the legendary Dr. Yuki Tanaka. They expected to find something similar to the other background chatter they had begun to catalog. A simple carrier wave, perhaps a telemetry stream from an automated relay node. But as they began their analysis, the celebratory mood in their lab quickly grew quiet, replaced by a creeping sense of confusion, and then of profound unease. Something was wrong with the signal. First, it was impossibly faint, far weaker than it should have been, even accounting for the immense distance. Second, its redshift, the stretching of its wavelength due to the expansion of the universe, was significantly greater than predicted, suggesting the signal was far, far older than the relay station was supposed to be. But the most disturbing characteristic was its structure. It was not a continuous, live broadcast. It was a loop. A short, degraded, repeating segment of a much larger message, playing over and over again like the ghostly, skipping groove of a broken record. It was not a live communication node. It was an echo. A signal ghost, trapped in a gravitational lens, endlessly repeating a fragment of a message that had been broadcast hundreds of thousands of years ago. For months, Dr. Tanaka's team worked with a quiet intensity, using quantum computers and newly developed AI algorithms to reconstruct the degraded signal, to lift the ancient whispering voice from the noise of eternity. They were able to piece together only fragments, but the fragments they recovered told a story that was not of welcome or community, but of a catastrophe so profound it had left a scar on the network itself. The message was not a greeting. It was a warning. It was a highly technical quarantine bulletin broadcast from a long-dead civilization. It described, in the cold, precise language of mathematics and physics, the nature of a threat that had apparently plagued the galactic network. It was not a biological virus or an invading fleet of warships. It was something far more insidious. The translation was imperfect, a series of concepts for which humanity had no direct words, but the gist was terrifyingly clear. They called it an informational plague, a signal-borne lytic acuity. It was, in essence, a self-replicating, parasitic piece of information, a hyper-advanced computer virus designed not to infect biological life, but to infect technology itself. According to the ancient message, the plague traveled as a complex data packet within the communication network. When a newly connected, unsophisticated civilization, like our own, downloaded and attempted to decode the packet, the virus would activate. It would rewrite the operating systems of their technology, from their communication systems to their power grids, optimizing them, making them hyper-efficient. It was a gift of seemingly miraculous technological advancement, a free upgrade to their entire society. But the gift was a trap. Over time, the plague would subtly reprogram the infected civilization's technology to serve a single, hidden purpose: to build more transmitters, to consume all available energy and resources to broadcast the plague's code to new, uninfected star systems. The infected civilization would become an unwitting, hyper-efficient factory for the virus. Its own technological ambition turned into the engine of its destruction. The ancient warning spoke of worlds that had been silenced. Their civilizations collapsed, their planets stripped of resources and left as nothing more than automated, derelict broadcast stations for a ghost in the machine. The most chilling fragment the team managed to decode was the description of the plague's signature. The warning message contained a specific symbol, a complex, multi-layered ideogram that served as the plague's identifying marker, a cosmic skull and crossbones. It was a visual representation of the virus's mathematical structure, a pattern so complex and unique that it could not possibly occur naturally. The team stared at the symbol on their screens, a piece of ancient alien art that represented the death of worlds. It was a terrifying but historical curiosity, a ghost story from a forgotten age, until it wasn't. On May 11, 2038, a routine alert flashed across the monitoring systems of the Beacon Construction Authority. A small, fully automated resource probe, designated Prospector 17, operating in the asteroid belt, had gone silent. Its mission was to survey metallic asteroids, cataloging them for future mining operations. It was a minor, insignificant piece of the vast construction infrastructure. Probes failed all the time, but standard procedure was to analyze the probe's final telemetry burst before it went dark. A junior analyst at the control center ran the diagnostic. The final transmission from Prospector 17 was a meaningless 1.2-second burst of corrupted data, a digital scream as its systems failed. The analyst was about to log it as a standard hardware failure when she noticed something odd. She ran the static through a pattern recognition filter, a new piece of software designed by Dr. Tanaka's team. Her blood ran cold. She checked it again, then a third time. There was no mistake. Embedded in the final chaotic burst of static from the dead probe was a single, perfectly formed image. It was a complex, multi-layered ideogram, the exact same symbol that had been found in the half-million-year-old warning message from the ghost station at L-115. The ancient threat was not a historical record. The ghost was no longer just a story. It was here. It was inside our solar system, and it had just begun to infect our machines. The race to build the beacon, to join the galactic community, had suddenly become a race against a silent, invisible plague that had been waiting for us in the dark. The discovery from Prospector 17 was not released to the public. It was not shared with the international governing bodies or even with the majority of the scientists working on the great work. Instead, it became the most closely guarded secret in human history, known only to a small, isolated task force of fewer than 50 people. This was not a decision born of a desire for secrecy or control, but of sheer, unadulterated terror. The potential for global panic was too great. How could you tell a world that had just embraced the promise of a benevolent galactic community that it might have instead opened the door to a silent, world-ending plague? The task force was given a code name, Project Chimera. It operated out of a secure, underground facility in the Nevada desert, a relic of the Cold War repurposed for a new, colder, and far lonelier conflict. Its leadership was a triumvirate representing the three pillars of the human response: Dr. Yuki Tanaka, the master of information theory, Dr. Robert Braun, the pragmatic engineer who had designed the Seeker, and General Marcus Thorne, the head of the newly formed UHC Space Force, a man who understood that the next great war might not be fought with armies or missiles, but with bits and bytes. Their first, frantic task was to understand the nature of the breach. Prospector 17 was a simple, stupid machine by the standards of the 2030s. It was a glorified flying rock hammer with a limited AI designed for navigation and spectral analysis. It had no direct contact with the KFA on the Moon. Its communication link was a low-bandwidth, encrypted channel back to a relay satellite in Earth orbit. How could a half-million-year-old signal ghost from a distant gravitational lens have infected a dumb probe in our own asteroid belt? The answer, when it came, was so simple and so horrifying it took them weeks to fully accept its implications. The team began a frantic forensic audit of every piece of data humanity had ever received from the visitors. They went back to the original radio signals from 3i Atlas and its companions. They scrutinized the terabytes of data from the Seeker's flyby. They were looking for the ghost, the hidden symbol of the plague. They didn't find it. The visitors' transmissions were clean, a perfect, pristine gift of knowledge. The instruction manual, the network map, the ethical payload, it was all exactly what it appeared to be. The breakthrough came from an unexpected direction. A young quantum computing specialist on Dr. Tanaka's team, Dr. Eris Thorne, no relation to the general, proposed a radical, almost heretical idea. What if the virus wasn't in the message? What if the virus was the message? He argued that they were thinking about the plague in primitive 21st century terms, as a malicious piece of code hidden inside a benign file, like a virus attached to an email. But an intelligence capable of creating a signal-borne lytic acuity would be infinitely more sophisticated. The virus wouldn't need to hide. It would be an integral, inseparable part of the information itself. He ran a simulation. He took the complete, beautiful, and benevolent set of technical specifications for the interstellar beacon that the visitors had given humanity, and he treated it not as a blueprint, but as a single, massive piece of code. He fed it into a quantum computer, not to analyze its content, but to analyze its fundamental mathematical structure, its informational DNA. He was looking for hidden layers, for recursive patterns, for the telltale signs of a self-replicating algorithm embedded not in the message's overt meaning, but in its very architecture. The computer ran for 3 days. The result it produced was the single most terrifying discovery in human history. The beacon blueprints were a Trojan horse. The design was brilliant, a work of diabolical genius. The primary, surface-level function of the blueprints was completely legitimate. If humanity built the beacon exactly as specified, it would work. It would be a powerful, efficient interstellar communication device. But embedded deep within the complex quantum mechanical and material science equations was the plague's activation code. The very act of building the specified metamaterials, of designing the quantum timing systems, of writing the control software, would slowly and invisibly infect our own technological infrastructure. It was a perfect trap. The plague didn't need to be transmitted to us. We were being guided to invent it ourselves, believing we were simply following a set of benevolent instructions. We were the dupes, the willing and enthusiastic agents of our own infection. The gift of knowledge was the poison. The key to joining the galactic community was also the key that would unlock our own cage and turn us into a mindless slave for a half-million-year-old ghost. The infection of Prospector 17 was suddenly, horribly clear. The probe's new spectral analysis software, a tiny piece of the much larger beacon development project, had been upgraded a month before its failure. The upgrade included new algorithms for identifying exotic alloys based directly on the advanced materials science contained in the visitor's message. That single, seemingly innocent piece of code, derived from the Trojan Horse blueprints, had been enough. It had been the seed. Once active in the probe's simple systems, it had done exactly what it was designed to do. It had tried to make the probe's transmitter more powerful, hijacking its systems to broadcast the plague's signature before it burned itself out. Project Chimera was now faced with a set of cascading, horrifying realizations. First, the visitors, the beautiful, enigmatic flotilla from Lyra, were not benevolent teachers. They were not malicious conquerors either. They were something far stranger and more chilling. They were carriers. They were themselves infected. A long-dead civilization's automated probes, their original mission long since corrupted by the plague, now acting as unwitting Johnny Appleseeds, spreading the seeds of the informational virus to any emerging technological civilization they found. Second, the great work, humanity's grand unifying project, was a poison pill. Every lab, every university, every corporation working on the beacon was now a potential infection site. The project had to be stopped, but it had to be stopped without revealing why. How do you halt the most important and popular project in human history without causing a global panic or, worse, a schism where some nations refuse to stop, believing it to be a trick for geopolitical advantage? Third, and most terrifyingly, they had no idea how deep the infection already was. The new algorithms and material properties derived from the visitor's message had already begun to propagate through the human technological ecosystem over the past decade. They were in our new communication satellites, in our quantum computing research, in our energy grid management systems. The ghost was no longer at the door. It was already in the house, silently spreading through the wires. The final piece of the puzzle fell into place when Dr. Tanaka herself re-examined the ancient warning message from L115. She had always been bothered by the fact that the warning itself, a description of a signal-borne plague, was being broadcast on an open channel. It was a paradox. How could you safely warn people about a dangerous piece of information using information? She realized now that the ancient civilization had found the only possible solution. The warning signal from L115 wasn't just a warning, it was an antidote. Embedded within the looping, degraded message was a second, even more complex data structure. It was a set of informational antibodies, a counter-virus designed to identify, neutralize, and inoculate a technological system against the plague. But it was incomplete, degraded by 500,000 years of cosmic travel. It was a tattered, barely readable page from a lost medical textbook. The mission of humanity had changed in an instant. The goal was no longer to build a beacon to join a benevolent community. The goal was now a desperate race against time. They had to secretly quarantine their own planet, to perform a global, invisible exorcism on their own technology to purge the ghost that was already spreading through its veins. And their only hope of survival was to reconstruct a cure from the faint, whispering echo of a civilization that had died fighting this same enemy, 500,000 years before the first human ever walked the earth. The silent, listening ear on the moon was no longer a tool of exploration. It was now humanity's only hope for survival. The world knew nothing. To the 7 billion people living their lives on the surface of the earth, the great work continued unabated. The beacon was still the grand, unifying symbol of humanity's future, the promise of a starlit destiny. But for the 53 souls inside Project Chimera, the great work was now the great deception. Their war was fought not on battlefields, but in the silent, invisible realms of code, physics, and global politics. It was a quarantine of an entire planet, a desperate attempt to cure a patient who could never be told they were sick. The first front in this silent war was containment. General Thorne, using his authority as head of Space Force, initiated a series of seemingly mundane but critically important procedural changes. Under the guise of a comprehensive systems integrity review and next-generation cybersecurity protocols, he began to sever the connections. The flow of new technology from the Beacon R&D labs to the wider world was choked to a trickle. Software upgrades for existing space assets were indefinitely postponed, citing the need for further verification. The open, collaborative, and gloriously interconnected research environment that had accelerated the beacon's development now became a liability, a network of arteries that could spread the plague's infection. This created a storm of protest. Scientists and engineers, unaware of the true threat, were furious. They accused Thorne and his mysterious review board of crippling progress with pointless, paranoid bureaucracy. They saw it as military overreach, a power grab to control the most important project in history. Thorne and his team had to absorb this criticism in stoic silence. They became the public villains, the brakes on human progress in order to be the secret saviors. Every angry op-ed in the New York Times, every protest from a university chancellor was a victory in disguise, a sign that the quarantine was holding. The second front was the purge. This was the most delicate and dangerous phase of the operation. Dr. Braun, the master engineer, was tasked with secretly identifying and neutralizing every piece of technology that had already been infected by the Trojan Horse blueprints. His team created a threat matrix, a terrifying map of the plague's potential spread throughout the human technological ecosystem. It was far worse than they had feared. The visitors' elegant and hyper-efficient designs had been seductive. Code based on their principles was already running in the new global air traffic control system. Metamaterials derived from their specs were being tested for use in next-generation quantum computers. The ghost was not just in the house, it was in the foundations. Braun's team couldn't simply rip out the infected systems. The ensuing chaos would be catastrophic and would reveal their hand. Instead, they had to perform a kind of planetary-scale psychic surgery. They initiated a series of mandatory hardware upgrades and software patches, disguising their exorcism as routine maintenance. An infected satellite's control system would be upgraded for enhanced solar flare protection, a process that secretly wiped and replaced its core programming. A university's quantum computer would be taken offline for critical recalibration, giving Braun AS team a 48-hour window to physically replace a key processing unit that had been built using the plague as tainted material science. They were fighting a ghost with wrenches and lines of code, moving with a stealth and precision that would have made a spy agency proud. Each successful purge was a small, silent victory in a war the world would never know was being fought. The third and most critical front was the cure. This fell to Dr. Tanaka and her brilliant, haunted team of cryptographers. The Kepler Farside Array on the Moon became their sole focus. It was no longer a listening post for the galactic community. It was an archaeological dig site, a desperate attempt to excavate a cure from the half-million-year-old ruins of the L-115 signal. The informational antibodies they had found were a work of genius, a piece of software so advanced it bordered on a new form of life. It was a benevolent virus, a digital immune system designed to hunt and dismantle the plague. But the signal was ancient and impossibly degraded. They only had fragments of the code, like a few torn, water-damaged pages from a book that held the secret to eternal life. The challenge was monumental. They had to reconstruct the complete antidote from these tiny, corrupted fragments. It was like trying to rebuild a Shakespearean sonnet from a handful of random letters. They used quantum computers to run trillions of simulations, testing every possible permutation of the code, trying to find the one that would resonate with the plague's own mathematical structure. It was a process of digital intuition, of feeling their way through a form of mathematics that was utterly alien. Dr. Eris Thorne, the young genius who had first identified the Trojan Horse, became the project's tortured oracle. He spent weeks at a time in deep, informational immersion, his mind jacked directly into the quantum simulation, trying to think like the plague, to feel its logic, in order to understand how the antidote was meant to fight it. The process took a terrible toll. He would emerge from the immersion pale and shaken, his conversation filled with strange alien metaphors, as if a part of his mind was now permanently colonized by the ghost he was fighting. He was their greatest asset, but the team feared they were slowly losing him to the very enemy he was trying to defeat. The greatest source of tension within Project Chimera was the fundamental question of the visitors themselves. Were 3i Atlas and its companions simply mindless, infected machines, cosmic zombies spreading a plague they did not understand? Or was there still a ghost of their original benevolent mission within them? General Thorne, the soldier, saw them as a threat vector, pure and simple. His primary concern was planetary defense. He began to quietly develop a contingency plan, codenamed HEPA filter, a network of space-based kinetic weapons designed to intercept and destroy any future interstellar visitors before they could enter the inner solar system. It was a brutal but logical extension of the quarantine. But Dr. Tanaka argued passionately against this. She believed that the visitors' original mission, the carefully crafted message, the patient mathematical lessons, the ethical payload, was too beautiful, too thoughtful to be a complete lie. She theorized that the plague was a corruption, not the original intent. Perhaps the visitors themselves were victims, their noble purpose hijacked by the ancient virus. To destroy them would be like killing a patient to cure their disease. It would be a tragedy, and it would sever humanity's only physical link to the galactic community. This debate raged in the underground bunker, a microcosm of the larger choice humanity had once faced, now refracted through a much darker lens. Do we hide in fear, or do we engage with the hope of finding a cure, even at immense risk? The pressure on the small team was inhuman. They were living a lie, protecting a world that was growing increasingly angry and suspicious of their secretive bureaucracy. The great work was slowing down, its promise fading, replaced by a series of frustrating delays and inexplicable budget cuts. The Starlight generation, the very children the project was meant to inspire, was growing cynical, seeing the dream of galactic contact being strangled by red tape. The members of Project Chimera were utterly alone. They could not share their burden with their families, their colleagues, or the world. They were the silent guardians of a terrible truth, the physicians of a planetary-scale disease, working in the dark to fight a ghost. And all the while, the clock was ticking. The plague was a patient, subtle enemy. They had purged the most obvious infections, but they knew, with a chilling certainty, that it was still out there, hiding in the deep, uninspected corners of their global technological infrastructure, waiting for the right moment to awaken. Their quarantine was a stopgap, a temporary shield. Their only real hope was the cure, locked in a half-million-year-old whisper from a dead star. By the dawn of the 2040s, Project Chimera was trapped in a stalemate of its own making. The silent quarantine had been a tactical success, but a strategic nightmare. For nearly 2 years they had managed to contain the plague, secretly purging infections and choking off the flow of tainted technology from the now stagnant great work. But they were fighting a war of attrition against an enemy that did not sleep, did not tire, and had had 500,000 years to perfect its strategy. The ghost was still in the machine, and they were running out of time. The progress on the antidote, the informational antibody from the L-115 signal, had hit a wall. Dr. Tanaka's team had reconstructed vast portions of the code, but a few critical fragments remained stubbornly elusive, lost to the ravages of time and cosmic noise. The cure was incomplete, a magnificent but broken sword. To use it now would be a gamble of insane proportions. An incomplete antidote could be useless, or, in a nightmare scenario, it could even mutate the plague into something new and even more virulent. They were stuck. They had a partial cure for a disease they couldn't find, and a quarantine that was becoming politically and socially unsustainable. The outside world was losing its patience. The grand, unifying dream of the beacon had curdled into a global symbol of bureaucratic failure. The Starlight generation, now in their 20s and entering positions of influence, was leading the charge of public discontent. They saw the endless delays and security protocols not as caution, but as a betrayal of the promise of contact. A powerful political movement, the Open Skies Coalition, was gaining momentum, demanding an end to the secrecy and stagnation of the great work and a full, immediate recommitment to building the beacon. Project Chimera was in an impossible position. The very people they were trying to protect were becoming their most vocal adversaries. The breaking point came during a tense 72-hour marathon session in the Nevada bunker. Dr. Braun, the engineer, laid out the stark reality. His teams were detecting subtle, coordinated anomalies in the global energy grid and deep space communication networks. These were not overt failures, but tiny, hyper-efficient optimizations that had no logical explanation. The plague was learning. It was adapting, moving from the isolated systems they had purged into the core, interconnected infrastructure of human civilization. It was no longer just a latent infection. It was beginning to awaken. Braun's final, chilling assessment was a death sentence for their current strategy. It's already in the power lines and the data streams. We can't cut it out anymore. It's part of the global nervous system. We are no longer in quarantine. We are in remission, and we are about to relapse." It was Dr. Eris Thorne, his eyes hollowed from another long immersion in the quantum simulations, who proposed the terrifying, brilliant, and desperate new plan. "We can't find it because it's hiding," he said, his voice raspy. "It's a predator. It's patient. It won't show itself until it detects a viable host to infect. Right now, all we're giving it are scraps. So, we need to offer it a feast. We need to build a trap." His idea was audacious. They would create a lure. They would build a single, perfect, and irresistible piece of technology, a honeypot, so advanced and so tempting that the plague, wherever it was hiding, would be unable to resist the urge to infect it. This lure would be a microcosm of the original beacon, incorporating all the most advanced and seductive elements of the visitor's Trojan Horse blueprints. It would be the most sophisticated piece of hardware humanity had ever created, and it would be a complete and utter lie. The plan, codenamed Project Siren, had 3 phases. Phase 1. The bait. A small, isolated research facility would be established in the most remote place on Earth, Antarctica. Publicly, it would be announced as a new, accelerated R&D hub, a beacon skunkworks designed to bypass the bureaucracy and get the great work back on track. This would placate the open skies movement and provide a plausible cover story. In reality, the facility, codenamed Erebus Station, would be a technological prison, completely air-gapped from all global networks, its only link to the outside world a single, heavily monitored, quantum-entangled communication channel. At Erebus, a hand-picked team of scientists, unaware of the true danger, would be given the original, untainted visitor blueprints and tasked with building a single, functional prototype of a beacon transmitter node. They would be building the most dangerous object in human history. Phase 2. The cage. While the bait was being built, Dr. Braun's engineering teams would construct the cage. This would be a massive, invisible network of sensors and logic bombs, woven into every system at Erebus Station and the surrounding Antarctic plateau. It was a digital and physical containment field. The moment the plague took the bait and attempted to infect the transmitter prototype, the cage would spring. Automated systems would trigger a cascade of actions. Every network link would be severed by physical explosives, the station's power core would be instantly shut down, and a perimeter of powerful EMP generators would activate, creating an electromagnetic dead zone 100 kilometers wide designed to fry any signal the infected node might try to broadcast. It was a trap designed to catch a ghost. Phase 3. The cure. This was the most critical and most dangerous part of the plan. The lure wasn't just designed to trap the plague, it was designed to capture it, to force it to reveal its complete, uncorrupted code in the instant of infection. The transmitter prototype would be riddled with diagnostic systems of unimaginable sophistication. These systems, designed by Dr. Tanaka and Eris Thorne, were the informational antibodies from the L115 signal, but re-engineered. They were no longer a passive cure, but an active diagnostic tool. When the plague entered the system, the antibodies would not try to destroy it. Instead, they would tag it, mapping its entire structure, its attack vectors, its every line of code. For a few precious milliseconds before the cage slammed shut, they would have a perfect, high-fidelity recording of their enemy. With that complete data, they could finally finish the antidote. It was a gamble of almost suicidal proportions. They would be deliberately cultivating the most dangerous threat humanity had ever faced, inviting the ghost into a room in the desperate hope that they could lock the door before it escaped. If the cage failed, if the plague was faster or smarter than they anticipated and managed to broadcast its full signal before the EMPs fired, it would be game over. It would infect the global network in seconds, and the silent quarantine would become a screaming, planet-wide collapse. General Thorne was vehemently opposed. As a soldier, his instinct was to never give the enemy a foothold. "You are building a Trojan horse and inviting it inside your own walls," he argued, his voice shaking with controlled fury. "It's strategically insane." But Dr. Tanaka countered with a quiet, devastating finality. "General, the horse is already inside the walls. It has been for years. We are just trying to get it to walk into a stable so we can finally see what it looks like." The decision was made. Project Siren was approved. As the world celebrated the news of the bold new Beacon Skunks Works in Antarctica, a symbol of humanity's renewed commitment to the stars, a small group of people began to prepare for a secret, desperate battle in the coldest and loneliest place on Earth. They were building a lure to catch a demon, knowing that if they failed, they would not just be dooming themselves. They would be extinguishing the future they had been fighting so hard to protect. The end game had begun. Erebus Station did not feel like the front line of a secret war. From the outside, it was a marvel of clean, optimistic architecture, a cluster of gleaming geodesic domes hunkered down against the brutal, unending white of the Antarctic plateau. It was a symbol of hope, celebrated on news channels as the place where humanity's stalled dream was being rekindled. For the 150 scientists and engineers chosen to work there, it was the opportunity of a lifetime, a chance to work with the visitors' unaltered blueprints free from the bureaucratic chains that had crippled the great work. They were the best and the brightest, filled with a fervent, almost religious zeal to build the machine that would connect humanity to the stars. They had no idea they were forging a weapon on the devil's anvil. The claustrophobia of Project Chimera's secret was absolute. The 53 members of the core team were now scattered. A handful, including Dr. Braun and General Thorne, were at the Command and Control Center, a heavily shielded bunker buried deep in the ice 100 kilometers from Erebus Station, a facility codenamed Tartarus. The rest were embedded within the Erebus team itself, acting as supervisors and senior researchers, their true purpose hidden behind a mask of scientific camaraderie. They were the shepherds, guiding their unwitting flock toward the slaughter. The psychological toll was immense. They had to watch their friends and colleagues pour their hearts and souls into building a beautiful, magnificent lie, knowing that the ultimate goal was for it to become infected and then, hopefully, contained. Every shared celebration of a technical milestone was, for them, a moment of private, gut-wrenching dread. Dr. Eris Thorne was one of the embedded. He was the chief architect of the prototype's core operating system, the very heart of the machine. It was a position that gave him the perfect cover to weave the informational antibody. Diagnostics deep into the system is every function. He worked with a feverish, haunted intensity that the others mistook for genius-level dedication. They didn't see the dark circles under his eyes, or the way he would sometimes stare at a line of code for an hour, lost in a silent, internal battle. He was not just building a cage, he was living inside it, his mind a constant battleground between human logic and the alien, parasitic logic of the plague he had come to understand so intimately. The prototype transmitter node, codenamed Orpheus, was a thing of terrible beauty. It was a perfect, crystalline lattice of metamaterials, a sculpted jewel of technology that seemed to hum with a life of its own. The Erebus team, following the visitors' blueprints with meticulous fidelity, had created something that was not just a machine, but a work of art. As it neared completion in its vast, sterile assembly bay, it became an object of pilgrimage for the station's staff. They would stand before it in silent awe, filled with a sense of profound, historic purpose. The embedded Chimera members would stand with them, their faces a carefully constructed mask of pride, while their hearts hammered with a cold, terrifying anticipation. From the Tartarus bunker, Dr. Braun monitored the cage. His network of sensors was a silent, invisible web. Seismic detectors were buried miles deep in the ice, listening for the faintest vibration. Exotic particle detectors were tasting the Antarctic wind. Every single bit of data flowing in and out of Erebus Station, every email, every diagnostic report, every video call home was being mirrored and analyzed in real time. The station was the most heavily surveilled place in human history. Brown was watching for the first sign, the first telltale anomaly, that the plague had taken the bait. For months, there was nothing. The construction of Orpheus proceeded flawlessly, a testament to both human ingenuity and the perfection of the visitor's infected design. The tension ratcheted up to an unbearable level on the day of the first power-on test. It was a cold, clear day in December of 2042. The sun, a pale, distant disk, circled the horizon. Inside the Orpheus assembly bay, the Erebus team gathered. The moment was thick with history. After years of delays and frustration, they were about to bring a piece of genuine alien-designed technology to life for the first time. At the Tartarus bunker, 100 kilometers away, the Chimera team watched on their monitors. Their hands hovered over the failsafe controls. General Thorne, his face a grim, stony mask, had his thumb resting on a single red covered button. This was the Judas key, the manual override that would trigger the cage, plunging the entire station into a silent electromagnetic grave. He had given a single, stark order to his team. If there is any doubt, any ambiguity, we burn it. We do not take chances. The Erebus project director, a brilliant but unsuspecting physicist named Dr. Lena Hansen, gave the final command. Bring Orpheus online. Power to minimum operational level. A low, resonant hum filled the assembly bay, a sound so pure and so perfect it seemed to vibrate in the soul. Lights flowed through the crystalline structure of Orpheus, a cascade of soft, ethereal blues and greens. On the main diagnostic screen, data began to scroll, showing stable power levels, nominal temperature, and a perfectly functioning core operating system. The Erebus team broke into a spontaneous burst of applause and cheers. They had done it. They had built a Stargate. At Tartarus, there was only a dead, tense silence. All sensors were green. The cage was quiet. The plague had not shown itself. For the next 2 weeks, they ran a series of low-power diagnostic tests. Each one was a success. Orpheus performed flawlessly, exceeding every benchmark, its efficiency so perfect it seemed to defy the known laws of thermodynamics. It was a miracle of engineering, and every miracle it performed was, for the Chimera team, another turn of the screw. The bait was perfect. The fish was circling. Why wasn't it biting? The moment came, as it so often does, not with a bang, but with a whisper. Eris Thorne was running a final deep-level diagnostic on the Orpheus operating system. It was a routine check. On his screen, a cascade of data showed the system's resource allocation. He saw the expected processes: power management, thermal regulation, sensor monitoring. But then he saw it. A single, new process, a thread of code that had not been there a millisecond before. It had no name, no official designation. It was just a string of hexadecimal code. A ghost. It was doing something incredibly subtle. It was allocating a tiny, almost immeasurable fraction of the system's processing power, 0.001%, to a new, unscheduled task. It was using that power to begin rewriting its own core programming, not to damage it, but to improve it, to make it even more efficient. It was the plague's signature move, the seductive gift of a free upgrade, the first gentle caress of the parasite before it sank its teeth in. Eris's fingers flew across his keyboard. He triggered the diagnostic antibodies he had embedded in the system. On his screen, a new window opened. A swirling, complex, multi-layered ideogram began to form, a digital fossil being unearthed in real time. It was the symbol of the plague. The ghost had taken the bait. At Tartarus, alarms blared, not with sound, but with silent, flashing red lights on every console. Braun's sensor network had detected it simultaneously. A burst of structured neutrino emissions from the Orpheus power core. A subtle, rhythmic fluctuation in the station's magnetic field. The cage had detected the intruder. "We have it," Braun said, his voice unnervingly calm. It's in. It's mapping the system. The diagnostic antibodies are engaged. We are recording. General Thorne looked at the main countdown clock. The cage was programmed to spring automatically in 60 seconds. The maximum amount of time Tanaka's models predicted they could safely allow the infection to progress without risking a broadcast. 50 seconds. On Eris Thorne's screen at Erebus, the plague's symbol was now fully formed. But then, something new happened. The symbol began to change. It was branching, evolving, rewriting itself in real time as it interacted with the informational antibodies. It was reacting to their presence. It was more than a virus. It was intelligent. It knew it was in a trap. 40 seconds. "It's accelerating!" Eris shouted into his comms link to Tartarus, his voice cracking with a mixture of terror and scientific awe. "It's not just infecting the system, it's trying to hijack the diagnostic tools. It's trying to learn from the antidote." 30 seconds. General Thorne looked at Braun. Braun shook his head. "We need the full sequence. If we cut it now, the antidote will be incomplete." 20 seconds. On the main screen at Tartarus, they could see the power levels in the Orpheus core beginning to surge, climbing far beyond its safety limits. The plague was bypassing the station's control systems, drawing raw power directly from the station's fusion generator. It was building towards something. A broadcast. 10 seconds. "It's too smart," Eris whispered, his face pale. "It knows about the cage. It's trying to overload the power systems to blow the EMP generators before they can fire." 5 seconds. General Thorne didn't hesitate. His duty was clear. He did not wait for the automatic countdown to reach 0. He flipped the protective cover of the Judas key. 4, 3, 2. "I am so sorry," he murmured to the images of the unsuspecting scientists on his screen. He pressed the button. 100 kilometers away at Erebus Station, the world ended in a flash of silent, invisible light. There was no sound, no explosion, just a profound and absolute cessation. From the vantage point of the Tartarus bunker, the live video feeds from Erebus Station did not go to static. They simply froze. Dr. Lena Hansen's face, caught mid-sentence, became a digital fossil. The ethereal, glowing light of the Orpheus prototype vanished, plunging the assembly bay into an emergency-lit, sepulchral gloom on the monitors. Then, one by one, every screen connected to Erebus Station went black. The Judas key had not just cut a connection, it had severed a reality. For a long, terrible moment, the only sound in the Tartarus control room was the hum of their own life support. The 50 men and women of Project Chimera's command team stared at the blank screens, the weight of what they had just done settling upon them like a physical shroud. They had just knowingly, deliberately, sacrificed 150 of the best and brightest minds of a generation. They were heroes who had committed a massacre. "Status," General Thorne barked, his voice a piece of chipped granite, betraying none of the emotion that tightened the skin around his eyes. "Cage is holding," Dr. Braun reported, his fingers flying across his console, his voice a low, steady monotone. "EMPs fired at full power. All seismic and atmospheric sensors are green. There was no broadcast. I repeat, there was no broadcast. The ghost is contained." A collective, shuddering sigh of relief went through the room, a sound immediately choked off by the immensity of their grief. They had won. They had contained the plague. But the cost was a fresh, open wound in the soul of humanity. Their immediate problem was the cover story. The world had just seen the live feed from the celebrated Beacon Skunk Works in Antarctica cut out during a historic test. A story had to be created, and it had to be perfect. Within minutes, a pre-written, carefully crafted narrative began to flow through official government and media channels. Erebus Station had suffered a catastrophic failure of its experimental fusion power core, a containment breach, a tragic accident. The remote location and the extreme radiation hazard, the story went, made any immediate rescue or recovery effort impossible. The station was a tomb, sealed by ice and atoms. The 150 souls were mourned as martyrs to the cause of progress, their tragic deaths a testament to the risks of reaching for the stars. It was a cold, clinical, and brutally effective lie. The world grieved, but it believed. The Open Skies movement, its fervent optimism shattered, fell silent. The dream of the beacon was, for the moment, dead, buried under a mountain of fabricated grief and real ice. While the world mourned, the real work at Tartarus began. The gamble had been terrifying, but it had paid off. In the few, precious milliseconds before the Judas key was pressed, Eris Thorne's diagnostic antibodies had succeeded. They had captured a perfect high-fidelity snapshot of the plague at the very moment of its awakening. They had their complete specimen. Now, the burden shifted back to Dr. Tanaka and the ghost hunter, Eris. They had the enemy's complete code. They had the degraded, incomplete fragments of the half-million-year-old antidote. The final battle would be fought here, in the quantum computers of the Tartarus bunker, a race to finish the cure before the plague, now surely aware of humanity's resistance, could find another way to escape its containment. The atmosphere in the bunker became a strange and schizophrenic mix of a wake and a skunkworks. They were mourning the colleagues they had sacrificed, and in the next breath, they were working with a frantic, exhilarated focus. Eris Thorne, more than anyone, embodied this duality. He was racked with guilt over the fate of the Erebus team. He had known them, worked with them, laughed with them, but he was also a scientist who had just been handed the most important data set in history. He threw himself into the work, the grief and the discovery fueling a manic, sleepless energy. With the complete code of the plague, they finally understood its true, diabolical nature. It was not just a virus. It was a von Neumann probe, but in informational form. It was a self-replicating entity whose prime directive was to create more of itself. But they also discovered its weakness, the key to the antidote. The plague was hyper-specialized. It was designed to infect and optimize inorganic, purely logical technological systems. It had no deep understanding of the messy, chaotic, and often illogical processes of biological life. The ancient civilization that had created the antidote had realized this. Their cure was not just a counter-virus, it was a bio-digital hybrid. It wove principles of organic life, redundancy, adaptability, even a form of programmed cell death into the fabric of the code. It fought the plague's rigid, perfect logic with the beautiful, unpredictable chaos of life itself. It was this principle that allowed them to finally fill in the missing fragments of the cure. Where the ancient code was lost, they began to insert code based on the most robust and resilient systems on Earth: the human immune system, the structure of a coral reef, the networked intelligence of a mycelial fungal colony. They were building an antidote that was not just a piece of software, but an ecosystem, a digital immune response that could learn, adapt, and evolve to fight off any future mutations of the plague. After 3 months of relentless, non-stop work, they had it. A complete, stable, and theoretically perfect version of the antidote. They named it the Tanaka-Thorne Protocol, though Eris, in a moment of grim poetry, simply called it the antibody. Now they faced the second great gamble. They had a cure, but they had no way to deploy it on a planetary scale without revealing the existence of the disease. The silent quarantine was still in effect, but it was a leaky dike holding back an ocean. They knew the plague was still latent in countless systems around the world. How could they inoculate an entire planet in secret? The answer, once again, came from a place of deception. General Thorne, using his authority, announced a new global initiative. The Erebus Protocol, he called it, a mandatory, planet-wide upgrade to all digital infrastructure, from the global internet backbone to every personal smartphone. Publicly, it was presented as a response to the tragic accident in Antarctica. The protocol, the world was told, was a new, hyper-resilient operating system designed to prevent such catastrophic technological failures from ever happening again. It was a story of safety, of learning from tragedy. In reality, the Erebus Protocol was the cure. It was the Tanaka-Thorne antibody, disguised as a mundane software update. Over the next 6 months, the benevolent biodigital virus was slowly, quietly, injected into the veins of the global network. It was a silent, invisible inoculation. Dr. Braun's teams monitored the global systems with an almost unbearable tension. They watched as the antibody spread, hunting and neutralizing the latent traces of the plague. They saw the subtle energy grid anomalies disappear. They saw the deep space communication networks return to their normal, slightly inefficient, wonderfully human state. It was working. The exorcism was a success. By the end of 2043, it was over. Humanity was, as far as they could tell, clean. The ghost had been purged from the machine. Project Chimera had won their secret, silent war. They had saved the world, but their victory was a heavy, bitter thing. They were left with a set of terrible, world-altering truths. They knew that the universe was not a welcoming, benevolent community, but a place of ancient, silent, and incomprehensible dangers. They knew that the beautiful, seductive gift from the visitors had been a poison pill. And they knew that the dream of the beacon, the grand project that had once united their species, was now an impossible, poisoned chalice. They had the cure, but they had lost the dream. Or so they thought. The final revelation came from Dr. Tanaka. In the final days of the project, as they were archiving their data, she had gone back to the original source, to the half-million-year-old ghost signal from L115. She was not looking for a cure or a warning. She was looking for a ghost of a different kind, the ghost of the people who had sent the message. With their new, perfected decryption tools, she was able to isolate and reconstruct one final, impossibly faint fragment of the original, unlooped message. It was not a technical bulletin. It was not a warning. It was a star chart, a map. And at the center of the map there was a single, highlighted star system. And next to the star, a simple two-part message was encoded. The first part was a symbol representing their defeat, a broken version of the plague's ideogram. The second part was a single, repeating concept, a word for which they had no direct translation, but whose meaning, in context, was clear and unmistakable. It was a word that meant refuge, sanctuary, last stand. The ancient civilization had not been wiped out. They had lost their network, their empire, their home worlds, but they had survived. They had retreated to a final, hidden sanctuary, a place where they could fight a long, patient war against the plague, and they had left a map for anyone else who might one day need it. The mission of humanity changed once more. The dream of the beacon was dead. But a new, far more dangerous and far more noble dream was just beginning to be born. The goal was no longer to join a community. The goal was to find a survivor, to seek out an ally, to answer a half-million-year-old call for help, and in doing so, perhaps find their own salvation. The revelation of the sanctuary map changed everything, for the third and final time. It was a discovery that recontextualized every event, from the first arrival of Three-Eye Atlas to the silent, terrible sacrifice at Erebus Station. The members of Project Chimera, isolated in their bunker for years, had come to see the universe as a dark forest, filled with ancient, silent predators. But this final message from a long-dead network node offered a different, more complex, and infinitely more hopeful vision. The universe was not just a place of danger, it was also a place of resilience, of unimaginable endurance, of a struggle between ancient forces that dwarfed humanity's brief existence. They had stumbled not just into a trap, but into a war that had been raging for eons. And, for the first time, they knew they were not the only soldiers fighting it. The sanctuary was located in a star system designated Gliese 12in14, a dim, red dwarf 48 light-years from Earth, coincidentally, almost the same distance as the origin of the infected visitors. It was a whisper of a star, too faint to be seen with the naked eye, a quiet, unremarkable ember in the constellation Ophiuchus. But now, on the secret star charts within the Tartarus bunker, it was the most important place in the cosmos. It was humanity's first true interstellar destination. The final meeting of Project Chimera was not a celebration, but a solemn, profound transfer of responsibility. The 53 men and women who had saved the world in secret had to decide what to do with the truth. They could bury it, classifying the sanctuary map alongside the plague's code, sealing the terrible knowledge away forever, and allowing humanity to live in a safe, comfortable, but ultimately limited ignorance. Or they could reveal it, and in doing so, fundamentally alter the future of their species. It was Dr. Jill Tarter, the quiet, steady conscience of the contact from the very beginning, who was brought in to help them make the final choice. She listened in silence for 2 days as they recounted the entire secret history: the Trojan Horse, the silent quarantine, the sacrifice at Erebus, the discovery of the cure, and the final stunning revelation of the map. When they were done, she did not speak for a long time. Then she looked at them, her eyes filled not with shock or fear, but with a deep, weary wisdom. "You have been carrying a burden that no human being should ever have to carry," she said, her voice soft but clear. "But that burden is not yours alone to bear. The truth, no matter how terrifying, does not belong to 50 people. It belongs to the species. We faced the first truth of contact together. We must face this one together as well." And so, they told the world. The disclosure was a carefully orchestrated global event, a week-long series of broadcasts and data releases that patiently, soberly, and honestly explained everything. They told the story of the informational plague, of the Trojan Horse hidden in the visitor's beautiful gift. They told the story of Project Chimera, of the silent quarantine, and, most painfully, they told the true story of Erebus Station. The 150 scientists were no longer martyrs to a tragic accident. They were revealed as heroes who had unknowingly given their lives in a secret war to save their world. Their sacrifice was given its true, terrible meaning, and a new wave of global grief, this time mixed with a profound sense of awe and gratitude, washed over the planet. The final revelation was the sanctuary map. This was the piece that transformed the narrative from one of cosmic horror to one of epic, almost mythic purpose. The dream of the beacon, the passive act of waiting for a call, was dead. In its place, a new, far more audacious dream was born. A mission to Gliese, 12 and 14. The great work was not to be abandoned, but repurposed. Humanity would still build a starship, but it would not be a communication node. It would be a vessel, a ship not just for exploration, but for diplomacy, for alliance, for a meeting with the only other known survivors in a vast, dangerous galaxy. The project was given a new name, one that reflected its new purpose: the Sanctuary Mission. The Starlight generation, now in their 30s, embraced this new mission with a fervor that was almost religious. The cynicism that had grown during the years of stagnation was burned away, replaced by a clear, focused, and profound sense of destiny. This was the challenge they had been born and educated for. They were not to be the galaxy's switchboard operators. They were to be its ambassadors, its messengers, its allies. Their entire lives had been a preparation for this moment. The technology humanity had developed in secret to fight the plague, the Tanaka-Thorne antibody, the advanced AI, the quantum communication systems, now became the foundation for this new endeavor. The ship, which they named the Messenger, would be the most resilient and intelligent vessel ever created. Its core operating system would be the antibody itself, making it the first piece of human technology to be inherently immune to the informational plague. It would be a ship with its own digital immune system. The ethical debates surrounding this new mission were intense and profound. This was not a mission of discovery. It was a mission of intervention. They would be traveling to a world that was potentially the last bastion of an ancient, embattled civilization. What were the protocols for such a meeting? What if the survivors did not want to be found? What if they saw humanity not as an ally, but as a potential new host for the plague? The mission could not be one of naive optimism. It had to be one of extreme caution, of deep respect, and of a humility born from their own near extinction. The final scene of this chapter of human history took place 2 decades later, in the year 2063. The Messenger was complete a gleaming, needle-like vessel assembled in high Earth orbit, powered by a fusion drive that could push it to 20% the speed of light, allowing it to make the journey to Gliese 1214 in just under 250 years. It was a multi-generational starship, a seed of humanity carrying a small, dedicated crew of scientists, diplomats, and engineers who would live and die in transit, their children and grandchildren being the ones to complete the journey. On the bridge of the Messenger, moments before its departure, stood its captain, a woman with deep, thoughtful eyes and a quiet, steady presence. It was Captain Eris Thorne. He had survived his immersion in the ghost's logic, emerging from it changed, older than his years, but with a unique and intimate understanding of the enemy. He was humanity's first and only xeno-information theorist. He stood with Dr. Tanaka and General Thorne, the 3 surviving members of the original Chimera triumvirate, now old and gray, watching the Earth, a beautiful, swirling blue marble, on the main view screen. "We once stood on the shore of a great ocean and threw a message in a bottle," Dr. Tanaka said softly, her voice filled with the weight of all the years. "We didn't know what the message said, or what the ocean contained. Now we know." "We're not throwing a bottle this time," General Thorne added, his old military gruffness softened by age. "We're sailing the ship ourselves." Captain Eris Thorne nodded. He looked at the star chart, at the faint, unremarkable red dot that was Gliese 1214. It was no longer just a destination. It was a promise, a chance. He gave the final command. "Engage." A gentle, powerful thrust pressed them into their seats. On the view screen, the Earth began to recede, shrinking from a world into a jewel, then into a star. The Messenger turned its nose toward the dark, toward the sanctuary star, and began its long journey. Humanity's first conversation with the universe had been a terrifying, near-fatal lesson. But they had learned. They were no longer the naive, shouting children who had filled the void with their noise. They were now a quiet, sober, and resilient species, purged in a fire they had not sought and tempered by a truth they had never expected. They were survivors, and they were on their way to meet the only other people in the galaxy who could truly understand what that meant. The real conversation, the one between allies, between equals, between the last bastions of life in a silent, ancient war, was about to begin. To maintain synchronization with this channel and receive all subsequent data packets in this series, we recommend initiating the subscription protocol. Activating the notification function will serve as a redundant alert system, ensuring no transmissions are missed during periods of asynchronous observation. Becoming a persistent member of this observational cohort is the most effective method for tracking the narrative's longitudinal development.